they are independent on each other. It is a different matter that oceanic currents, by warming up the waters, can lead to cyclonic circulation. But then again, the air circulation which will happen in its own independent way. Pradeep, it varies. That is what we studied yesterday, didn't we? Day before yesterday. Simran, yes. Once they die, once the corals die, basically after that, they are nothing but a piece of calcium carbonate. Prasan, not required for general studies. The pelagic deposits, the neritic deposits, benthic deposits, not required for your general studies. Polymetallic nodules, however, we will study in minerals and industries. You will get an idea. Yuvika, Indian climate is the most dynamic. Kirtesh, you can revise the portion of climatology from the tablet or from the book. It will help you out. Namrata, no. Because when you consider the entire of the oceanic corals, very small. Rough map of India and the world, you can always draw. We will cover it. Prachit, in today's session, we will cover it. Muskan, gyre is where you have a circular motion. In a thermal, you have turning circulation. Gyre, generally, you will find closer to the surface. So there you have the fundamental of the entire Ekman transport and Ekman spiral. But then again, because it is not needed for your general studies, so we have not covered that. Not very important, Sajal. EMOC is a kind of a thermohaline circulation, Shanavas. Abhijit, in prelims questions, they vary. Sometimes you will find more questions coming from Indian geography, sometimes more from physical geography. Manoj, that is what generally is observed. Triple dip El Nino and triple dip La Nina, basically, Manisha, they are when you have recurring seasons of La Nina or El Nino due to certain conditions of the Pacific, and you have the jet streams involvement as well. But overall, when you have triple dip La Nina, you generally experience a larger amount of rainfall. Ajay, yes, for basics, it will be more than enough. Ubaid, for optional, anyways, in between 3 to 4 months, you have to consider. Ocean currents, Nitya Krishna, we have seen the type of questions. Ideally, you should be able to know the different ocean currents, whether they are warm and cold, and which ocean do they move. Anjali, whatever resources and resource distribution for the entire world, we will take a look at the major ones in the mapping, more than sufficient. You can always browse through that to increase your knowledge. Yuvika, we did study about the coral islands yesterday, didn't we? Okay, regarding the books that 6th to 10th NCRT or 11th and 12th NCRT, if you are able to understand 11th and 12th NCRT, which I think you should be able to once you have attended the sessions, it will be very easy for you. Then you don't need to go for 6th to 10th. If you are unable to understand 11th and 12th, then pick up the 6th to 10th. Yes. Yes. Nitya Krishna, they are slightly different, but then you can explore more. Pratik, if you want to display Indian Ocean phenomena, then you can simply take up the Northern Indian Ocean map and the rough boundary of Africa and Southeast Asia. That will do. Anubhav, that is going to be more than sufficient. Abhay, your question is not clear. You're not able to convince us, then should I? Abhay, it is up to you. It is your choice, and I'm not binding you to the sessions. Please understand, eventually, you have to study, and the eventual aim should not be that whether I am conveying something or not. Your aim at this point of time in your life should be very clear. What should be done by you in order to clear the exam? Whatever convinces you that this decision will help me clear the exam, absolutely go for it. If that means not attending the sessions, if that means taking help from somewhere else, absolutely go for it. Because eventually, please understand, we are not here to satisfy anyone's ego. We are here to clear the exam. So if the concepts are not being cleared in the class, if there is no way that I can extend my help to you, you are free to take your own path. Vibhor, yes. Okay. Now, so hello, good evening to all of you, and welcome to Byjus Exam Prep. Welcome to another session of geography, where today we shall be entering into the realm of Indian geography. So all the portions of geography that we have read till now, that culminates into this particular unit of Indian geography. The Indian geography overall is a kind of a broader application of the portions that we have covered in the earlier aspects of geomorphology, climatology, or even oceanography. Now, there, one of the prime reasons why UPSC wants you to study all those portions of physical geography is so that you can understand India in greater detail. Otherwise, what will you do if a candidate has got very good idea about what is present in Canada, what is present in Australia? UPSC has got absolutely no role or no use for that once you become officers. So, why UPSC wants you to study about the entire phenomena of the world is so that you can understand this particular aspect of geography in a better way. Now, Indian geography is going to be vital both for your prelims as well as for your mains examination. So when we talk about Indian geography, here what are the portions that we are going to cover? Indian geography in itself is a composition of all the aspects related to India. So broadly in this Indian geography, first of all, if you have to absolutely divide the portions of Indian geography, first comes the portion of physiography. Physiography. Okay? That is where we study the various different landforms. Type of been asked, but nowadays we find that mains questions are also being framed from this area. Then you have climatology. Right? Climatology. Then after that, there we have already dealt with the seasons and the monsoons of India. Seasons and monsoon. This is something we have already covered. Then you have rivers and drainage system. drainage systems. Then after that, you have the portion of biogeography in a way, that is soil and forests. Then after that, you have the portion of minerals and industries, where we will study the factors which leads to industrial location, mineral distribution, the major minerals which are present, the minor minerals which are present, metals, non-metals, all those basic things we will study in this. Then comes the portion of population, settlement, and transport. I forgot one basic thing that again we read here, and we will spend much significant amount of time in that actually, and that is the portion of, right? So this portion of agriculture, minerals, industries, population, settlement, and transport, that is what is oftentimes categorized in the form of human and economic geography. So we are going to study that as well. So these are the various portions that you are required to know as a candidate, as an aspirant for civil services. Now here, one by one, we shall be covering up each and every portion which is there, one by one. So today we shall be starting with the physiography. Climatology is something that we have already done. So after physiography, we will be jumping on into the drainage systems. We will try to understand what are the basics regarding the drainage systems, what kind of drainage patterns are in existence, what are the properties of Himalayan rivers, why is it that the Himalayan rivers always end up flooding, what is the principle behind interconnectivity of the rivers, the basic property of all the river channels, major rivers across the country. Then after that, we shall study the different soil types, its distribution, forests. The state of forest report again is something that we will be deliberating upon. Agriculture is where I will be spending considerable amount of time, where I would want to have a kind of a discussion with you guys, a kind of a mature discussion with you guys, where we are not bounded by our very narrow political lines and where we are able to think on a larger scale. That is where we will spend a lot of time, because UPSC has been concentrating upon agriculture significantly in the past few years. Then minerals and industries is again something where industrial location is something that UPSC is focusing. So there again, we will spend more amount of time. Population, settlement, and transport regarding population density, population distribution, migration, the type of urban settlement, rural settlement, these are going to be very basic. Now, in this portion of Indian geography, let me tell you guys beforehand that look, the PPTs in general, I have tried to make it text heavy so that it helps you revise properly. Having said that, whenever you do face any kind of difficulty in the session, you can always take a look at the same portion in the tablet as well, where you will get that amount of idea. Any doubt which persists, you can feel free to ask me in the session. You can mail to me as well. You can mail to us in general. But in Indian geography, that is the approach which we are going to follow. Overall, for Indian geography, I would want you to keep your eyes and ears open for current affairs. Even in the mains examination, the role of current affairs is very significant. And this is something I have already highlighted multiple times, that when you are preparing, prepare for the mains exam. Prelims, if your luck is very bad, if you have prepared well, maybe you are out of luck, so 1 year you might not get into the prelims. But if your preparation is up to the mains level, right, up to the main standard, you will always prevail. So for current affairs, I would always suggest you that read the newspapers on a daily basis, if possible. Try to look through a couple of magazines as well, right? Down to Earth is one such magazine which helps you significantly understand the portions of, let's say, agriculture, soil and forest, regarding, let's say, the drainage systems. So Down to Earth will be providing you with those current affairs, which will also help you in the portion of environment and ecology. Okay. Now, for those, and we have quite a significant number of you regarding the aspect of, for example, when we talk about optional portion of geography, many of you are interested in optional. So for those of you, you can always study Indian geography for current affairs from a magazine that we have as Geography and You. So that magazine also you can take the help of. Okay. Now, Tanmay, we have already, biogeography I have already cleared. Everyone please understand, biogeography, we will cover the portion of soil and forest that comes under the purview of it. But majority of the portion of biogeography, see this classification that you have, that this is the portion of biogeography, etc., etc. At once, try to take a look at the questions, right? What are the questions that appear? If you are able to attempt those questions with the materials that you have read otherwise, what is the need for it? So the rest of the portions of biogeography is covered in very significant detail in environment and ecology sessions. So you can attend that and you can cover that. Regarding the portion of universe, stars, etc., science and tech will do the bidding. Okay? Right. Human and economic geography basically is in the portion of, from all the portion of agriculture all the way till transport. That is going to be a part of human and economic geography. Okay. So, having said that, let us initiate our discussion without further ado about the physiographic divisions and location of India, which will come into the first portion of India's geography. Major physical features of the world we have already covered, right? With the portion of fold mountains, with the aspect regarding the climatic distribution, regarding the mineral distribution we will do in the mapping, but otherwise most of them has been covered with the help of geomorphology, climatology and oceanography as well. Okay. Maria, that depends. Overall marks of mains and interview is counted. So if you score extraordinarily well in mains, even if your interview marks dip, you will get through. So that is where the fight is. It is about mains. Okay. Now, having said that, let us initiate the discussion. So today we will be talking about the physical features of the country, physical features across India. Now here, we are going to follow an approach which is very similar to that of geomorphology. So those of you who have attended geomorphology, who have revised geomorphology, for you it will be a very easy task. And basically in NCERT and also for the examination perspective, just knowing the physiographic divisions oftentimes is more than sufficient, is more than enough. At the end of this discussion, we will also be discussing about how to prepare for the examination from this particular chapter. As much as possible, I'll try to guide you regarding what kind of preparation is needed. But the approach that we are going to take here, the approach is going to be slightly different from what you find in the case of your textbooks, from what you find in the case of your reference books. So please don't try to mix and match that it is present in the book, it is not present in the book, etc., etc. So in the very initial stage, I am telling you that we are going to dig up till the absolute bottom. We are going to start from the basic regarding, if we, let's say, talk about Peninsular Plateau, how the Peninsular Plateau came into existence. If we talk about Northern Plains, how is it that the Northern Plains came into existence? If we talk about the Western Ghats and the Eastern Ghats, why do they have such features? Why is it that the continental shelf is wider across Arabian Sea as compared to Bay of Bengal? So we will get to the bottom of when, where, why, and how of it, right? Now, while we do that, please understand that for general studies, UPSC won't be asking you a direct question that please tell us about the formation of Peninsular Plateau. For general studies, such type of questions are not asked. But having said that, if you have a detailed idea, a detailed analysis of the formation of the Indian subcontinent in itself, that will put you in a very good position to tackle with the portions of economic geography, human geography as well, that why is it that the northern plains are poor when it comes to mineral distribution? Why is it that the Peninsular Plateau is so very rich in mineral deposits, be it the region of Jharkhand, Odisha, Chhattisgarh, Karnataka? The Peninsular Plateau is well endowed with mineral deposits, whereas it is not the case across northern plains. You don't find much minerals in, let's say, Uttar Pradesh, Uttarakhand, etc. So all those portions will be absolutely clarified once you understand the basics regarding formation. That will be the endeavor. But again, I will attach a caveat. If somehow it appears to be burdensome to few of you, that I'm not able to understand properly that how the plateau has been created, please don't worry at all, because such direct questions won't be asked. As far as possible, if you would have read NCERT or the basic books, mostly it is to do with the naming of it. That where is it that Deccan Trap is present? Where is it that Karnataka Plateau is present? So such kind of simplistic questions are there. Some year or the other, UPSC might throw a bouncer at you. For example, this year, UPSC asked a detailed question regarding Deccan traps. So in those cases, it might help. But otherwise, you don't need to worry significantly that I don't know what he is teaching and I'm not able to understand or follow about it. So don't worry about it at all. Okay. So let us start with, first of all, the location of the country. So India as a country, we know about its location. As of now, I'm sure all of us would be very sure about the location of the country. So India is a country which lies entirely in the region of the northern hemisphere. The extent of the country, that is from south to north and from east to west, the extent is roughly around the same. So you have the mainland starting somewhere around 8 degrees 4 minutes north, and the topmost portion is at 37 degrees 6 minutes north latitude, right? And the east to west extent is again around 68 degrees 7 minutes east to around 97 degree 25 minutes east. That is the extent of the country. Now, that is the longitudinal position and the latitudinal position of the mainland of India. Having said that, we also have a group of islands such as Andaman, Nicobar, Lakshadweep. Now, Andaman Nicobar has the lowest, or in a way, the southernmost extent of India lies in the 4 minutes north in the region of Nicobar Islands. That is the southernmost tip. Kanyakumari, however, is at 8 degree 4 minutes north. Okay. Now, Tropic of Cancer runs almost through the center of the country. Now see, observe here. And this will give you a clue regarding how to approach Atlas. For example, you came here across the sentence that Tropic of Cancer passes through the center of the country. Immediately, the curiosity which should erupt in your mind is that let me open up the Atlas, obviously not in the middle of the class, but after the session maybe, open up the Atlas, trace the Tropic of Cancer. In the Atlas itself, look at where the Tropic of Cancer passes through. Observe the states where it passes through. For example, I'm sure many of you would not be aware or would have basically misplaced it in your memory that Rajasthan is another state through which Tropic of Cancer passes through. So this will give you an idea about the mapping as well. Okay, so whenever we come across any portion of Indian geography, immediately the curiosity should be where is it situated in various parts of the country, and that will give you a much detailed knowledge, a much detailed idea than what I can impart to you or what the books can impart to you. So always maintain that basic level of curiosity. Okay, now here after this, when we talk about India, we have to understand that every different country, remember the first session that we had, we talked about that how each and every country basically has got its own time zone. That is with regards to the Greenwich Meridian time, the GMT, the prime meridian that we have. So in our case, the meridian or the longitude which has been chosen as the standard time zone, that is the one which passes almost to the central portion of the east-west extent of the country. So that is the meridian which passes through basically here. This is the standard time zone. right? The standard meridian. It passes through the region around Allahabad and it touches various states. So again, the curiosity should apply that which states do this meridian or does this meridian pass through. So look at these particular and maintain your own list. Please don't rely upon a list, let's say circulated by me or circulated by any other coaching class. Have your own particular list when you in yourself, in your own capacity, you try to explore the map. But having said that, as we were talking about the north to south and the east to west extent, remember I told you that almost both of them are similar in terms of their extent. So you will find that the extent of north to south of the country is close to around 3214 kilometers, 3214 kilometers, whereas the east to west extent is again close to around 2933 kilometers. So it is roughly the same. Okay, not exactly the same, but roughly the same. So the standard time zone for the country, that is something which passes through in between the 68 degree 7 minutes east and 97 degree 25 minutes east. In between that, you have the standard time zone. Generally, the mean is taken. So mean of the extreme points of these two longitudes is how much? Around 82.8 degree. But that is not taken. The closest one is taken, that is 82 degree 5 minutes east, is taken as the standard meridian. This is the standard meridian which passes through the country. And this standard meridian passes through various different states. So when we talk about the states through which the standard meridian passes through, observe that you will find that it passes through the states of Uttar Pradesh. It touches the border of Madhya Pradesh, the bordering district of Madhya Pradesh, Chhattisgarh, Odisha, and then you have Andhra Pradesh. Many of the candidates I have seen, they get confused that the standard meridian also passes through Telangana, but it does not. So this is where a prelims type of question can always be framed here, and you have to be at your point, at your level best. Okay? So here you have Uttar Pradesh, Madhya Pradesh, Chhattisgarh, Odisha, and Andhra Pradesh through which the portions of standard meridian does pass through. Having said that, there are two states through which both the standard meridian as well as the Tropic of Cancer passes through. Right? There are two states through which both the standard meridian as well as Tropic of Cancer passes through. Which are those two states? You have Chhattisgarh and Madhya Pradesh. These are the two states through which the standard meridian as well as the Tropic of Cancer does pass through. Having said that, there is only one state where you have the Tropic of Cancer intersecting with the standard meridian. So if you observe, the Tropic of Cancer crisscrosses the standard meridian. In which state? It is the state of Chhattisgarh. Okay, that is where the Tropic of Cancer meets or intersects with the standard meridian. Okay, it is not UP, it is Chhattisgarh. Okay, so MP and Tropic of Cancer and the standard meridian will pass. Chhattisgarh is the state through which and in which both of them will intersect each other. Okay, now when we talk about the location of the country, India as a country has got a large coastline as well as a large territorial boundary. So when we talk about our neighbors, which we will study or which you would have studied in significant detail under IR, so basically, as you move from west to east or east to west, let's say we move from east to west, we have our neighboring regions in Bangladesh. Bangladesh is the country with which we share our largest land boundary, that is with Bangladesh. Then you have Myanmar, then you have China, Bhutan, Nepal, then you have Afghanistan for a very small distance, then you have Pakistan. These are the territorial boundaries, national boundaries, the territorial landmass that India shares. Now, when we talk about the coastal states such as Maharashtra, Karnataka, Kerala, Tamil Nadu, Andhra Pradesh, Odisha, West Bengal, Do these coastal states, will they have an international border or won't they have an international boundary? What do you think? Yes, they will have, right? Even across the coastline, you do have the international boundary. So please don't get confused when we say that almost all the states have an international boundary with them. Please don't always think about that, okay, but where is the international boundary in the case of Karnataka? Where is the international boundary in the case of Andhra Pradesh? Which is written underneath it, that is the boundary or up to a distance of 12 nautical miles, you have those as territorial waters. Beyond that, you have the international waters which start coming in. So that is where you do have the international boundary even across the coastal areas. Having said that, there are 5 states out there which don't share any international boundary. Which are those states? You have Haryana, you have Madhya Pradesh, you have Chhattisgarh, you have Jharkhand, and you have Telangana. These are the 5 states which don't share any international boundary of any sorts. Delhi NCR also is one of those areas which doesn't share any international boundary. Other than that, all the different states, they share either one or multiple international boundaries. For example, when you take the case of the state of West Bengal, West Bengal is one of those states which shares its boundary with Bangladesh, which shares its boundary with Nepal, which also does share its boundary with Bhutan, right? So it has got 3 international boundaries. Similarly, in the case of Sikkim, for example, Sikkim shares its boundary with Nepal, Bhutan, as well as China. Similarly is the case with even Arunachal. Arunachal will share its boundary with Bhutan, Myanmar, as well as China. So you have few of the states which share multiple international boundaries. Okay? All of this will be very, very clear if you take a look at the political map of India. So that again is a very basic where everything will be clarified. Now, having said that, when we talk about the land boundaries of the country, basically, they extend from west to east across various different nations. The largest land boundary that we have is with the neighbor Bangladesh. Okay? Bangladesh is the one with which we have the largest boundary. Here again, many candidates, they do commit mistakes. They do commit an error because primarily they think it would be either China or Pakistan because that is what is constituted in our daily conversation. Our conversation starts with China, ends with Pakistan. So that is where many of us, we have an idea that, okay, this would be the largest international boundary, but it is Bangladesh. Okay, keep that in mind. And the shortest international boundary is with Afghanistan. Afghanistan is the one with which we share the shortest international boundary. Okay? Now, here, when we talk about the region of Afghanistan, here again you have to understand that this is a kind of a contentious issue which always flares up between the perpetually warring states of India and Pakistan. We are always at loggerheads with each other, right? When something bad happens to Pakistan, we rejoice. When something bad happens to us, they celebrate and they rejoice. So that has been the topsy-turvy relationship. So even the boundary region with Afghanistan that we share, so there again, you have a very contentious issue with Pakistan. Pakistan, for its part, maintains that, look, India is not one of those countries which shares boundary with Afghanistan. Why is that? Why is it that Pakistan makes such statements? That is because if you take a look at where India shares boundary with Afghanistan, this is the small area. This is the small region with which India shares the international boundary with Afghanistan. Okay? This is where we share the international boundary with Afghanistan. Now, Pakistan's point of view is that, look, much of that area is under Pakistan-occupied Kashmir. So basically, you will have, or you no longer have a natural boundary. But in our opinion, which is rightly so, the will of the nation, the parliament, as well as the government stand is that the entire Jammu Kashmir is an integral part of the country. So, having said that, we are natural neighbors of Afghanistan. This is the logic that India puts forward whenever we go for any kind of international delegation, any kind of international summit dealing with Afghanistan. India expects itself to be a natural partner, a natural invitee in such delegations because we are neighbors of Afghanistan. We share historical and cultural ties with Afghanistan, and we share our natural borders as well. So again, this has been a tussle point. Now, when we talk about the boundary with Afghanistan, that boundary region in itself is very interesting geographically and in a way of taking a look at it physiographically or topographically. If you observe here the boundary of Afghanistan, you will observe there is a kind of a very thinned out boundary zone here, right? And the entire country then almost opens up. So this narrow panhandle shaped landform or region, this is what is also referred to as the Wakhan corridor. Wakhan corridor is that part of Afghanistan with which Afghanistan is able to share its boundary with Pakistan, India, China, and also Tajikistan and so on. So basically, here when we talk about Wakhan corridor, basically this has been a corridor which has been used historically for thousands of years. For all the European travelers and tourists historically who went from Europe for trading purposes all the way to the Mongol dynasty in China, they would travel through the Wakhan corridor. Because if you observe the terrain around here, you have Karakoram, Hindu Kush, Suleiman, Kirthar, Altai-Shan, Kunlun-Shan, everything around that Wakhan corridor. So that Wakhan corridor, even though it is at a height of close to around 4,000 meters above sea level, but still it provides a kind of an easier passageway, easier journey to take from the region of Afghanistan to the region of China. Even when you read history, I'm sure you would read about the Venetian traveler Marco Polo. Marco Polo, in his detailed account, had described about this Wakhan corridor and how the entire caravans, they used to move through the region of Wakhan corridors. More history when you explore about the Huns, more history when you explore about, let's say, the Mongols, etc. You'll find that it is in this region that they dominated, but because of the unfavorable terrain to the south, they never ventured into India. So that is why all the invaders, be it the Turkish invaders, be it the Mughals, all of them, they invaded the country via the region of Pakistan. They would never invade from the region of Wakhan corridor because the terrain is very harsh there. Now, recently, this has been in news because China, with its ever-expansive infrastructural plans, China is planning a route, a kind of a transport route from the region of this Wakhan corridor directly into Pakistan. Because as of now, China gets its access to warm waters of Arabian Sea by a highway which was constructed way back in the 1959 and 1960s, which passes through the Karakoram Pass of the Pakistan-occupied Kashmir. And this is the one which goes to Pakistan and through the Gwadar port. It ensures trade and trading activities with the rest of the world. So this particular Karakoram highway is something which passes very close to Indian borders. And that is something which has got China concerned. So that is why China, in order to find an alternate and a kind of an all-weather connectivity, is trying to have a connectivity through the region of this Wakhan corridor. That is why Wakhan corridor keeps on coming in news time and time again. Okay. Now, when we talk about the location of the country, location of India provides India with a certain amount of geopolitical and geostrategic advantage. And that advantage is humongous, and that is only owing to the location of the country. right? Without going into significant theories and details regarding the what is required for an ideal strategic advantage, we will not go into that. But if you think about it logically, basically, of all the oceans, first of all, in a very layman's term, in a very like childish terms, all the oceans that you see around the world, none of the oceans are named after any country. It is only India which has got an ocean named after it. So that tells you the importance of location of India. And India sits atop the Indian Ocean. Majority of the world trade across the globe by volume, that happens through oceanic routes. The trade majorly does not happen through land boundaries or through air connectivity. Majority of the trade, bulky trade, always takes place through the oceanic routes. So when that trade happens, it happens very close to Indian coastline. And that is when the ships, they pass through this particular area. Now that provides India with a unique set of opportunities, both in terms of security as well as in terms of economy. How? So you have very large ships which go on a long voyage, maybe from the region of Netherlands in Northern Europe, Rotterdam port in Northern Europe, all the way to Singapore, the Changi port of Singapore. So they would crisscross the Suez Canal, they would pass through the Red Sea, the Gulf of Aden, and then they would enter the Arabian Sea, and then they would move on to Singapore. In that journey, the ships always take a break. They require a break in order to replenish the fuel, replenish the stock supplies, and also a required break for the sailors which are present. Indian coastline has got the potential to provide them with that ideal break. Indian coastline provides them the opportunity that you can take a break here. Let's say you can come to Mumbai, you can go back, or you can maybe come to Mangalore, you can go back to either Kochi, and then you can go back to your route. Now, what this will do is, this will significantly enhance the economic demand and the economic output in these coastal states. And that is owing to the location of the country, nothing else, nothing more. Now here, when we talk about the other factor, other opportunity of having this sea route or having an ocean directly underneath us or to the southern extent of our location, the other aspect is being a net security provider. Basically, when we talk about the entire phenomena and the entire principle and doctrine of Indian Navy, where Indian Navy aspires itself to be a net security provider, what do we mean by that? We basically mean that all the way from the Gulf of Aden, all the way till Malacca Strait in the east, Gulf of Aden in the west, Malacca Strait in the east, that is where majority of the sea trade does happen. Now, Malacca Strait is very, very close to the southern extent of India. This is where the ships, they move through the region of Malacca Strait. All the trade to China will eventually pass through the region of Malacca Strait. So that is where Indian Navy portrays itself to be a net security provider. That look, be it the scourge of, let's say, piracy, global piracy, where the ships are hijacked and they are held for ransom and then later they are released after that ransom is paid. So be it protection against piracy or be it any humanitarian and disaster relief operations, India has got it covered. So that is why, be it a cyclonic disturbance and a cyclonic disaster which happens in Mauritius, to maybe the Operation Rahat which was initiated in Yemen where civilians of more than 26 countries were evacuated, India was amongst the first and the most monumental player in that entire activity. So our role in the Indian Ocean is not only restricted to the portion of economic benefits. Economic benefits is something that we have been accruing from this region, not today, not for the past 10 years, but for more than 1,000 years now. If you study the historical conquest and exploits of the Cholas, the Chola Empire, the mighty Chola Empire, right now, Cholas, they are becoming again very popular on all social media, etc., etc. So that mighty Chola Empire, it is considered, and it is famously said, that for them, Bay of Bengal was as if it was a backwater lake for them. That was the level of dominance that the Cholas had. In fact, it is through this maritime route where in the Middle Ages and even in ancient India, you had sailors who would move out all the way from Odisha and all the way from Andhra Pradesh and Tamil Nadu, and they would then carry on their trading activities to eastern part of Asia, even to China and as far as South Korea. So for us, trade through the oceans has been a historical phenomena, a historical behavior. We have cultural ties which extend beyond the boundaries through these oceans. We have cultural ties with countries such as Indonesia, Thailand, Mauritius, where many of our citizens, and people of Indian descent, they have basically migrated and they have lived there. So we have historical and cultural ties which is strengthened by the Indian Ocean, which is not distanced by the Indian Ocean, but we think of it as our community, as our neighbors. And it is in this aspect where India's whole doctrine of having a blue water navy, a naval force which can go for expeditions far away from its own boundaries, that comes into play. In the entirety of the region of the Indian Ocean, Indian Navy is the strongest and the most dominant force. It is because of this ability and this location that India has got a very unique advantage of blocking the trade route of many different countries. For example, when we take a look at the trading activities and the trades that Chinese they carry out, majority of the materials that reach the Chinese ports across the eastern coastline of China, they travel very close to the Indian coastline and they eventually move through the Malacca Strait. Now observe how close Malacca Strait is with Nicobar Islands. India has full military deployment and full military presence in the region of Andaman Nicobar Islands. And this is done so that if push comes to shove, if let's say we don't have much of an option or much of an advantage upon us and China is turning out to be more and more belligerent, with the help of our naval force, with the help of our air force, we can impose a blockade. When we impose a blockade here, basically that will strangulate any kind of trade which goes to China, and China's economy will take a substantial hit. So that is where India holds an advantage. Even in the case of our neighbor, the other neighbor, that is Pakistan, our western neighbor, it was during the 1999 Kargil war, where the outcome of the war was being dragged longer than what the government wished. Indian Navy was deployed, and Indian Navy was very close to enforcing an overall blockade of the Pakistani coastline, so that any ship which would go towards Pakistan would have to pass through Indian boundary. That is the power, or that is the role and importance that this vast ocean provides to us. But not only in the case of, let's say, Pakistan or China or the Indian Ocean, even our vast land boundaries, they provide us with a huge set of opportunities. After all, one of the greatest strategic thinkers of all time, that is Alfred Mahan, who was basically one of the strategic thinkers of United States to have lived in the previous century. He provided it very succinctly. He said that the country who will dominate the oceans will end up dominating the entirety of the world. And that is when the prophetic saying and the prophetic proverbial thought that the 19th century belonged to the Atlantic, the 20th century belonged to the Pacific, it is the 21st century which shall belong to the Indian Ocean. If we hold that thought closer to us, we will be aware that what the future holds for us, right? And if you think about it logically, 19th century, why do we say it belonged to the Atlantic? Because the countries across the bordering areas of Atlantic, be it the European powers, be it, let's say, United States, all of them, they grew in the 19th century. They were the world powers. When we say 20th century belonged to the Pacific, We mean countries such as Japan, countries again such as United States, countries such as, let's say, South Korea and on. All of these, they started exerting their power. Even USSR of that time started exerting its power across the Pacific. But the 21st century, owing to the demography, owing to the population distribution, owing to the economic power, is going to belong to the Indian Ocean. And India, sitting atop the Indian Ocean, will have a very unique and a positive future going ahead. So the location of the country provides us with a very unique set of advantages, right? The land boundaries, if you look at it, the land boundaries, which extend for more than 6,000 kilometers, provides us with a unique advantage with our neighbors as well. For example, take the case of Nepal or Bhutan. These are landlocked countries. Now, if Nepal has to carry out any trade on a large scale, it will need to have an access to the water body. That is where the trade will be carried out. So it will necessarily have to move its goods through India. That is where sometimes our foreign policy also takes a hit when you had in 2017 Nepalese conflict in a way, or the Nepalese disaster in a way, where Nepal started and had adopted a newer constitution. India enforced an economic blockade of all the things going towards Nepal. And that is when Nepal experienced a kind of a runaway inflation, where the inflation rate for petroleum, for other fuel items, for medicines, etc., absolutely increased and skyrocketed through the roof. It also provides us with a unique advantage in the sense of trading opportunities. Trading opportunities not only within our boundary, but also within international boundaries. You have already in plan and in place various projects being implemented which can connect the northeastern part of the country to the central mainland of the country, and that will pass through Bangladesh. Similarly, with our northeastern states, there is already a plan afoot to have a connectivity with the Southeast Asian nations such as Myanmar and Thailand. Again, an advantage of location. Right? It is this advantage of location which in not let off. It is this advantage of location which puts us at a different pedestal altogether. Right? We have our island territories in the form of Andaman, Nicobar and Lakshadweep. While Indians, we have a general habit of not appreciating something which is given easily to us. We always appreciate something which is hard fought. Right? So island territories and its strategic advantages, that is still not fully exploited. But if you look at the contemporary powers of the world, all of them, they are vying for control over some island or the other. Because once you control an island, your reach significantly extends exponentially. So the island territories of India, that also provides us with a unique set of advantages. Okay? Now, why I'm saying all this is because questions have been asked directly in the aspect of India's locational advantage. Questions have been asked in general studies, questions have been asked in the optional paper, and questions have been asked and framed directly even in the case of the essay paper. So India sitting atop Indian Ocean, what are the advantages, etc. All those aspects you have to put to paper when you write the answer for this. Okay? I hope this is something which is clarified. Okay? Now, more of it, I'm sure you will be covering in international relations. You will be covering all these things in detail. I'm sure about it. So that is where we'll restrict the locational aspect of geopolitics and geostrategy. Now, we come to the portion of physiography. What do we mean by physiography? When someone tells physiography of India, what do we exactly infer by that? So basically, physiography of an area is representative of the structure, process, and the stage of development of the topography. So it is a geological structure. It is the geological process and the geological outcome which you find in any area. That is what is physiography. From north to south, from east to west, we have a country, and we are a country which possesses it all. From loftiest of the mountains in the world to the driest of the deserts, from the rainiest areas in the region of Meghalaya to the marshlands of Gujarat, we have got all different kinds of physiography. From areas which are heavily forested and which are present in the deep interior of the country to the areas across the islands in Bay of Bengal and Lakshadweep, we definitely are a diverse lot. It is famously said that in India, if you move, let's say 100 kilometers, the language changes, the dialect definitely changes, and the food also changes. The traditions change. That is what constitutes us all. That is what binds us all together. It is that diversity. That is why India is oftentimes also referred to as a subcontinent. It is not because of the size of India. You have many countries which are larger than India, but you never refer to them as a subcontinent. You refer to Indian subcontinent. Why? Because the subcontinent that we talk about, it is not just the land that we are talking about. It is the people, the unique customs, the traditions, the cultures, the climate. All of that is so varied across that entirety of the landscape that in itself forms a subcontinent. Now, what if I were to tell you that all the various aspects of economy, society, culture, tradition, all of them is nothing but an output of the geographical feature? Now here, when I say geographical feature, I mean a sum total of geological feature as well as the climatic factors. After all, it is the geological features which give rise to various climatic factors, climatic conditions of rainfall, dry conditions, and so on. That is why each and every part of the country has got its very own unique method of celebrating any particular day, any particular event, any particular custom. So everything is driven from the basic physiography. Overall, across the country, the physiography can be divided into 6 major portions. To the north, we have the ever-alert northern frontier of the country, dotted with the Himalayan mountains, the mightiest and one of the young-fold mountains across the globe. So you have the northern and the northeastern mountains guarding our borders, not since today, not since the past decade, but historically. You will come across many different expeditions launched in history where you had invaders trying to come to India, but they were defeated in their will and purpose by that ever-enlarging guard that we have on the north, that is the Himalayan mountains. Then when we come to the south of the Himalayan mountains, we come across one of the most fertile tracts to be found across the entirety of the globe, and that is the vast northern plain, which stretches from the west in Punjab, where it is broader, all the way to the region of Bay of Bengal, and that is where we have significant amount of population density, significant amount of population which lives in that area. To the southern part of the country, we have that Peninsular Plateau, which has a kind of a volcanic origin. This Peninsular Plateau is not only the oldest landform that we have in our country. This Peninsular Plateau, it is estimated, is amongst the oldest landforms across the entirety of the globe, not only in India. It is said that the formation of this Peninsular Plateau is something which began close to around 3.5 billion years back. In fact, as per few of the latest studies which have been conducted, few of the researchers have also proposed and postulated that the region around Jharkhand, that is the Singhbhum region bordering Jharkhand and West Bengal, that might have been the first land mass to have been created or to emerge above water body. That is how old the Peninsular Plateau is. So that is why Peninsular Plateau is amongst the richest regions across the globe when it comes to minerals and resources. Then we have the very dry and vast Indian desert, which was not always historically a desert, but that desert formation has happened quite recently as the Indian plate has moved to its new position. Then we also have the island tracts of Lakshadweep and Andaman Nicobar, and we also have the coastal plains close to the Ghat section, right? So all these have their own unique set of advantages. All this has got a very unique set of attributes. That is something we are going to study. When we say peninsula, that is a landmass surrounded by water body on three sides. That is what is referred to as peninsula. Remember, I told you to mark Iberian Peninsula in the region of Spain and Portugal, and Yucatan Peninsula in the region of Mexico. So that is what is peninsula. That is why when we refer to the part peninsular India, we basically refer to the southern part of India. Okay? Now, let us start with the portion of the Himalayas. The Himalayas, quite easily, are the loftiest mountains across the globe. The Himalayas have been created as a result of the process of folding of landmass. You had a continental convergence which happened, where the Indian plate collided with the Eurasian plate somewhere around 50 to 60 million years ago. And at that point of time, some part of the water body which lied in between them, that is the Tethys Sea, that also got uplifted, and you had a series of other foldings which created a series of parallel mountain ranges. So if you observe the Himalayas, at least the three ranges which we consider a part of the Himalayan range in total, the three ranges, if you consider, they are the ones which run almost parallelly from west to east. These three ranges, which run parallelly from west to east, if you observe, these are present in the entirety of the stretch. The stretch spans close to around 2,500 kilometers from west to east, but they have a kind of a convex kind of a bend in between. And that bending indicates the type of collision which happened, right? It is said that initially the collision happened in the northwestern extent. This is where the Indian plate had collided with the Eurasian landmass. This is where the first folds happened. But then, because there was obstruction by the Eurasian landmass which was experienced here, the entirety of the Indian plate that started moving from the eastern part. And that is when the remainder of the ranges, they were created as a result of folding action. And that is why you have the folds here as well. Now, these Himalayan ranges, if you will notice here, the basic axis of the ranges. Axis represents the kind of the central portion of the ranges. You will observe that the axis of the ranges, they turn quite significantly in the region of northeastern part, right? And also here in the region of Pakistan. So this sudden change in the axis, where the axis or the directionality of the mountains, they suddenly change, these are also what are referred to as syntaxial bend. They are referred to as syntaxial bend. So Himalayas, they have two syntaxial bends. What is syntaxial bend? A syntaxial bend is that kind of a change in direction in the alignment of the mountains, right? Sudden change in the direction of alignment. So that is observed around the region of Namcha Barwa, which lies here. Namcha Barwa in the east, and around the region of Nanga Parbat in the west. That is where the syntaxial bend of the Himalayas is observed, where their general direction, their general alignment in itself, that undergoes a massive change. Now, these three ranges that I have been repeating about, what are these three ranges called? So when we talk about these three ranges basically are the Great Himalayas, which is also referred to as Himadri, This is the tallest of them all. And this has been created amongst the three ranges. This has been formed the earliest. The folding in this region is expected, or rather is estimated to have begun anywhere close to around 50-55 million years back. Then you have the middle ranges, which is the middle Himalayas, or what we refer to as Himachal. Then you have the one which has been formed the latest, the most recent one, which has been formed close to around 15 million years back, and that is the outermost, the outer Himalayas, or the Shivaliks. Right? These are the three parallel ranges which are in existence. Having said that, if you observe, you have some mountain ranges even to the north of it. Right, even to the north of Great Himalayas, you have some mountain ranges. For example, you will have the Karakoram range, you will have the Ladakh range, you will have the Zaskar range, and you also have the Kailash range. Now, these three ranges, if you observe, they are present in very small areas. They are not as continuous as is the case with the three ranges that we have talked about. Right? So they are intermittent, discontinuous, and also limited to a smaller portion. That is why the entire four portion, or these four areas, that is the Kailash range, or rather the Karakoram range, you have the Ladakh range, you have the Zaskar range, as well as the Kailash. These are what are referred to as trans-Himalayas. Trans-Himalayas. Meaning, what is the meaning of trans? Not with the one with the TRANCE, not that trans I'm talking about. I'm talking about TRANS. So this trans basically refers beyond, right? Something which is beyond, across. So that is what is represented here. So these are the trans-Himalayas, beyond the main Himalayan ranges. Okay? Now these Himalayan ranges, since they have been formed and they are in a process of being formed for a long period of time, they are nowhere stable land masses. These are very, very active seismologically. That is, these are the places where very frequent and high magnitude earthquakes, they are experienced. Be it the Kangra earthquake, be it the earthquake in Kathmandu, be it the earthquake in Darbhanga, be it the earthquake in Assam, the entire territory is dotted with multiple different earthquakes. In fact, if you look at the written records, they date back as early as 1299 AD, where a very massive Kathmandu earthquake is talked about, where it talks about the destruction of 2/3 of the Nepali kingdom because of these earthquakes. That is because this landmass is not stable. This landmass is still under plate. As we talk about, Indian plate is still colliding with Eurasian landmass at a speed of close to around 2 centimeters a year. The Indian plate is still moving into the region of this Eurasian landmass. As a result of that, the folding continues to happen. Whenever there will be a significant crustal movement, the crustal movement will happen only after a significant amount of friction is overcome. So that releases massive amounts of energy, which we feel in the form of earthquakes. But having said that, this is the reason why these three ranges that we talked about, these three ranges, their height is still increasing. And as you will see very soon, there is a fourth range which is about to be created to the south of the Shivaliks. Okay, so let us take a detailed look at the Himalayan ranges. Okay, now Pir Panjal are part of the Himalayan ranges themselves. Then when we talk about the entirety of the Himalayas, they do consist of the Himalayan ranges and the northeastern hills. The Himalayas consist of a series of parallel mountain ranges, parallel continuous. That is why Trans-Himalayas, they are not included in them, because the Trans-Himalayas, they are intermittent, restricted to an area, and they are not continuous. General alignment orientation of the mountains from northwest to southeast. Length of the Himalayan range is approximately 2,500 kilometers, and width varies between 160 to 400 kilometers in various areas. And here you can take a look at this particular itself, and you can understand that where the width will be greatest. The width of the fold and the mountain is highest, is greatest across the western extent as compared to the east, where the width is very small. That is why if you ever happen to visit, let's say, northern part of West Bengal, right? Or if you ever happen to visit, let's say, the region of Nepal, you will observe that suddenly as the plain ends, you have very lofty mountains which are in existence. Whereas if you go to visit, let's say, Uttarakhand, or if you go to visit Himachal, you will get to know from very large distance that, okay, entering a mountainous area, I can see few mountains, the smaller ones, you will be able to spot Shivalik. Then after you cross the Shivalik, you will be able to spot the larger Himachal ranges. When you enter into the Himachal, that is when you will be able to take a view of the lofty great Himalayas. But in the eastern part, even if you are in the northern portion of the plain region of, let's say, West Bengal, you will be able to have a sight of the great Himalayas because it is much more compressed. Now, many of you have been asking this question repeatedly. So here, let me tell you that why is it that the shape is like this? Try to understand it. But again, I will repeat, if you are unable to understand it, please don't worry about it. A direct question is not asked from this. This is just for your understanding that why there is a syntactical bend, why the shape is like that. I can see many questions. That is why I am going to address that. So here, when we talk about it, let's say this was the Eurasian landmass. You had the minor Burmese plate, Eurasian plate. And you had the Indian plate. Which had a shape somewhat like this. Now, as the Indian plate was moving north, at this point of time, the speed was very significant. The speed was close to around 10 centimeter per year. Now, as it moved north, it experienced a kind of an obstruction here at this area. Right? It experienced an obstruction in the northwestern portion. Now, as it experienced an obstruction, what happened? Folding was initiated in this area, right? Some folding was initiated. But the rest of the plate simply swiveled around. Think about it. When you have two solid objects which collide, one of them offers an obstruction, but the other solid object is still in a way of motion, what happens? The back portion swivels. If ever you have ridden a bicycle or a scooter or a motorbike, basically, when you suddenly apply the front brakes, what happens? Many of you fall down. That is a different matter altogether. But what happens when you suddenly apply the front brakes? Your rear wheels, they take a sideways, isn't it? I hope all of you can relate to it. So that similar motion happened. So eastern portion then swiveled. And that is when a collision happened across the eastern side. And that is why, while the northern portion continued to push, you had a reinvigorated motion across the eastern side. That is why a collision happened across the eastern boundary. And that is why the mountains that you see, these mountains have a kind of a shape. These mountains have a kind of a shape which comes like a convex, again, because the east has swiveled, the east has collided. That is why you have the collision across the east. And it is this collision which eventually leads to the Andaman Nicobar Islands as well. That is why the Himalayan plate, or rather the Himalayan ranges, they have a syntaxial bend in this region as well as in this area. You will find the existence of syntaxial bends. Right? This is where you have syntaxial bends. Okay. Now, after this, when we talk about the cross-sectional reach and the cross-sectional extent of the Himalayas, this is the cross-sectional extent, where if you observe, you have the Tibetan highlands, the Tibetan plateau, then you have the Kailash range, the Brahmaputra Valley, which moves in the region of the Kailash range. You have the Ladakh range, again a part of Trans-Himalayas. Then you have the greater or the inner Himalayas. This is the loftiest amongst them all. And here, the folding had happened or was initiated earliest. Immediately after collision, the folding had been initiated here. Then after some time, another subsequent folding happened at middle or lesser Himalayas. Then after some time, around 20-30 million years later, you had Shivalik or the outer Himalayas which got folded. This is the reason why, as the folding began much later, that is why if you will find the Shivaliks are much smaller as compared to the middle Himalayas, which are much smaller as compared to the great Himalayas. Right? Now, in between these, you find what is mentioned as MCT, MBT, and HFF. What are these? These are basically fault lines or cracks which have been created on the ground surface. These are also what are referred to as thrust faults. This is referred to as the main central thrust. Main central thrust. This is referred to as the main boundary thrust. And this is referred to as the Himalayan frontal fault. Himalayan frontal fault. Now these get created. These are basically cracks on the ground surface. Whenever there is any crustal movement, any movement of the Indian plate, you experience very heavy earthquakes, very massive earthquakes across these regions. That is why the very famous Kathmandu earthquake or rather infamous Kathmandu earthquake talk about, that happened because of crustal movement across the MBT. The very disastrous Bihar earthquake of 1934, which claimed thousands of lives, that again happened because of movement across MBT. You have many minor and small earthquakes which keep on happening in the region of northeastern states of Assam. That happens across HFF. Many of the times you have smaller earthquakes which happen in the region of Uttarakhand. That happens either across HFF or MBT. So what are these? And how are they created? These are what are referred to as thrust faults. And these get created when the rocks, which eventually will get folded into the mountains, these rocks also have a kind of a capacity to get deformed. Beyond that extent, they cannot get deformed. For example, if I consider this pen in my hand, I consider this as a rock. And let's say I go for deformation of this, folding of this. Will I be able to achieve that? I will be able to bend it slightly. But beyond the point, if I start pushing it, if I start bending, what will happen? The pen will break. right? Because it is not elastic. Similarly, the rocks are not also elastic. So when the rocks, they reach their deformity limit, or the limit up till which they can get deformed, beyond that, when pressure is applied, rocks will simply end up breaking. So that is experienced in this case. So let us understand how is it that these thrust faults, they get created. So first of all, these are cracks which appear due to compression as a result of the rocks the limit of deformation and experiencing forces beyond that. Right? So this is basically the aspect of the thrust faults. How do they get created? We consider the landmass which is colliding, right? Let's suppose we have the Indian plate, and let's suppose you have the Asian plate. Now, when they will move and they actually did collide, at that point of time, what happened was that there was a folding of the crust. The folding of the crust in the portion which created the first fold, that is the fold of the Great Himalayas. At the same time, it led to significant amount of crustal thickening, which happened here. Now, the movement did not stop here. The movement continued, the collision continued. As a result of that, as the movement continued, the height of the fold kept on increasing. But then after a point of time, at this joint, the rocks could not get deformed anymore. Because this is not like a simple tissue paper that you have, or a simple paper which you have, let's say, where it can get folded endlessly. If you fold a tissue paper, what happens if you apply forces to the tissue paper? Observe here. Because it is very soft, it will get folded into a kind of a fold, right? But what if when we talk about a solid or an object which cannot get folded to that extent? So there you had a significant amount of obstruction, which was, or a kind of a limit of deformation which was experienced here. And that is where you had the rocks which cracked. The rocks simply cracked open. Now, as the rocks, they cracked open meant what? Basically, here you had a fault line or a crack. So as then further movement happened, you had some movement here as well, right? Some movement which further folded the mountain, further increased its height as well. And simultaneously, as the movement continued, you had the land folding beyond it. And you had the formation of the Himachal fold. This again continued for some time, where the height of the Great Himalayas, they increased quite substantially. This happened, in fact, for many millions of years, right? Not for few years, not for, let's say, few centuries, etc., not for a few millennium, but for a few millions of years. So you had the establishment of rivers which had started coming down these mountain ranges in this time. This continued. And the movement also continued. So as the movement continued, the rocks here across this fault, they would move, but there was significant pressure experienced here as well. And that is when the rocks could not get deformed anymore, and the rocks, they cracked here as well. So further movement, what it led to? Further movement led to a further expansion or increase in the height, a kind of a motion across these fault lines, which caused earthquakes, and simultaneously you had the emergence of the newest range of the Himalayas, which we refer to as the Shivaliks. Right? So this is what was referred to as the MCT, or the main central thrust. This is what was referred to as the MBT, or the main boundary thrust. But then the Shivaliks, they got created 15 million years back. Since 15 million years, the Shivaliks have been in existence. The height of the three ranges of the Himalayas have been increasing. So naturally, the region around Shivaliks, here again, you had development of another crack. And this is what we refer to as HFF, Himalayan Frontal Fault. Okay? Now, what this tells us is basically one thing, that in the near future, you will have a fourth range of Himalaya which shall arise beyond the Shivaliks. So in the present day region of southern part of Uttarakhand, northern part of Bihar, northern part of West Bengal, Assam, in the coming years, you will have a fourth range of Himalayas which shall rise from there. And this we get to know because there is movement happening across the Himalayan frontal fault. How do we get to know about the movement? By recording the seismic activities. Now, you know any significant seismic activities across MCT, but you will find many seismic activities happening across MBT and HFF. And in the coming days, such seismic events are set to increase as there is a lot of deformation which is trapped within the rocks, which will get released once the rocks start to move. Okay? And by the way, when I say in the coming years, I mean to say in the next 5 to 10 million years, you will have another range of Himalayas coming up. Okay? So this is basically about the formation of the thrust faults across the Himalayan mountains, which is the cause of major earthquakes happening across the entirety of the stretch of the Himalayas. That is one of the reasons why the Himalayan ranges are so very prone to earthquakes, and that to massive earthquakes. Right? Unlike the region of the Peninsular Plateau where you have the earthquakes of very meager magnitude, there in the region of Himalayas you have massive earthquakes, which oftentimes leads to destabilization of the slopes. The slopes not only are very steep, but the slopes are also unstable, due to which natural disaster happens in this region? Which natural disaster happens because of this? You have frequent landslides. This is the reason, one of the reasons why when we talk about the Himalayan ranges, the Himalayas, they experience very frequent landslides because the land in itself is not stable. The slope is very steep. So any kind of instability will lead to materials coming down the slope with increased velocity, and that is why we have so many landslides. And because the slope is steep, remember the topic of mass movement, and you will also have severe orographic rainfall during the time of the monsoon. So lot of rain, lot of water component, steep slope means mass movement, means materials will start moving in bulk. That is the reason why Himalayas experience so frequent landslides. Okay? HFF, MBT, MCT, this is the full form, guys. Main boundary thrust, Himalayan frontal fault, and main central thrust. Okay? Now, Now let us cover each of these individual ranges and let us cover the features in detail. So the Himadri, which is the tallest of the range, that is why, because it has experienced so much compression, this Himadri is not only the tallest but also amongst the narrowest. You will find that basically it has got a width of only around 25 kilometers. And the average height, not the tallest, average height is around 6,000 meters above sea level. In fact, across the entirety of the globe, maximum number of more than 7,000 meters peak that lies in this. That is why this Himadri is flocked by tourists and expeditioners from across the globe. Now, not only in the Himadri, but across all the three ranges of the Himalayas, you will observe something very unique. If ever you get an opportunity to visit this region, you should absolutely take that opportunity regardless of come what may. But because we have the Indian plate which continued to move towards the Eurasian plate, as the Indian plate continued to push into the Eurasian plate, due to that, what happened? You had a kind of a topography where the southern slope is much steep as compared to northern slope, right? So in all the ranges, you will find a kind of a topography where the southern slope is steeper as compared to the northern slope. So this kind of topography is also what is referred to as the hog back topography. Okay, that is what is also referred to as hogback topography, which you find across all the three ranges. Why the southern slope is steeper? Because it is the Indian plate which is pushing into the Eurasian plate. That is why. Now, the folds of the Great Himalayas are asymmetrical in nature. Look at some of the highest peaks which are present in the Himalayas. You have Mount Everest, the tallest peak, Mount Kanchenjunga, which is the third highest peak in the entire world. Second highest peak, I am sure we would be knowing about that. Which is the second highest peak? Good. It is K2 or Godwin Austen. So then you have Makalu, Dholagiri, Nanga Parbat, all of them, they lie in the Great Himalayas, right? Now, then we have the middle ranges, which is referred to as the Himachal or the lesser Himalayas. These started getting created, these started folding after the formation of Himalayas had already happened. So when we talk about the Himachal ranges, the average height is lesser than the Great Himalayas. Why? Because the formation of fold started or was initiated much later. So that is why the average height is slightly lesser. It is mainly composed of highly compressed and altered metamorphic rocks because of huge amount of pressure which has been exerted. You have many different hill stations existent in this area, and these ranges, they are named by, or they are known by different names in different parts of the country. For example, you have the Pir Panjal, which forms the longest and the most important range that lies in the region of Jammu Kashmir. Then you have the Dhauladhar, which extends into Himachal Pradesh. Then you have the Mahabharat ranges, which extend all the way into Nepal Himalayas as well. And this is where you have the very famous Valley of Kashmir, the Kangra and the Kulu Valley in Himachal Pradesh, which is very well known. All the various hill stations such as Lansdowne, Dalhousie, even for that matter, the northern extent of Missouri, all of that lies in this region. Okay? Now, difference between Great Himalayas and Greater Himalayas. Where did you get this? Great and Greater Himalayas. Great Himalayas are the ones which are basically the Himadri as they are referred to. Okay? If you want to put much of the portion of much reverence and much respect if you want to put, then you can put Greater Himalayas. Right? Now, then the last of the folds which has happened in these series of ranges, that is the Shivaliks. That is why the Shivaliks, they still in majority have the presence of sedimentary rocks. Many of these rocks, basically, they were the sediments of the rivers which were originating after the Great Himalayas and the Middle Himalayas. They had already come into existence, because remember, when we discussed the formation of the folds, you had millions of years which actually spanned in between the formation of the earlier two mountain ranges and then the beginning of the third fold. So in the meanwhile, you already had massive river systems originating from these mountains. These rivers would bring back sediments, and these sediments would form a kind of a sedimentary deposit. It is only when the folding happened that these sedimentary deposits, they also folded to form Shivaliks. That is why the Shivaliks, they are said to be constituted or composed of unconsolidated sediments brought by the rivers from the main Himalayan ranges located further north. Okay? It has a lowest height, but then the height of all the ranges, that is continuously increasing. Okay? Now, yes, Dasgupta, the Himadri is the longest range, right? Now, after that, when we talk about the Shivaliks, these Shivaliks, just like the case of Himachal, they are known by different names. The ranges, they are known by different names from west to east. The Shivaliks are also almost continuous. It is only in certain portion across the eastern region between River Tista and River Raidak. That is where the Shivaliks are absent. Otherwise, the Shivaliks are almost continuous from west to east. So they are referred to by Jammu Hills in Jammu, Dhang Range and Dundwa Range in the region of Uttarakhand. Then you have the Churiya Ghat Hills of Nepal. And then you have Miri, Mishmi, Abor and Dafla in Arunachal, where they are named after the local tribes. Okay, so that is basically the formation of the Shivaliks. Now, once we have taken a look at the properties of these, now let us try to understand the individual landforms, the very unique landforms that you end up finding in these areas. So amongst the unique landforms, we have dunes and duars, you have Karewas in the region of Kashmir, you have Chos, which is a seasonal stream which is in existence in the region of the southern slope of Shivalik, and you also have the alpine grasslands, which generally you will find in the middle Himalayas. So let us make ourselves familiar with this. You want a break now? Okay. Ravi Teja, you can't remove the background color in the PPTs. You have been asking this for a long time. Okay. Now, Razia, it is River Tista and River Raidak. Thanks, Abu. Now, here we talk about the landforms created, which are very, very specific to the Himalayan region itself. And these are created in small areas, in small batches, in a way. You won't find these landforms to be very extensive for thousands of kilometers. So let us try to understand how these landforms, they came into existence. What were the various processes which come into existence when you had these landforms getting created? So here, when we talk about dunes and duars, before anything else, let me clarify, both of them are the name of the same landform. The same kind of land feature, when it develops in the region of Western Himalayas, they are referred to as dunes. And when they develop in the region of the Eastern Himalayas, they are referred to as duars. Let me repeat it again. Both of them are very similar landforms. It is just about their location that they are named differently. Okay, so what are these? These are basically depositional landforms. These are basically depositional landforms. Created as a result of deposits. Now let us try to understand how they got created, how they came into existence. So we have already talked about the fact that you had the creation of Middle Himalayas as well as the Great Himalayas, or if you want to put it, Greater Himalayas or Greatest Himalayas. So the earlier two ranges had been created much earlier, and Shivaliks, they came into existence much later. And that time span was for around 15 to 20 million years. So when we talk about these different types of landforms, so they got created as a result of the river action. Let us look at it. Let us try to visualize how they got created. So initially, basically, you had the existence of the earlier mountains, the high mountains. Now, from these high mountains, you already had the movement of rivers, right? Rivers had started coming in. And the rivers had started originating in this area. Now, these rivers, as they carried on, these rivers basically carried the sediments and all the various deposits further down the plains. But then the fourth range or the third range of the Himalayas, they started coming into existence, and the further fold, which led to the creation and formation of Shivaliks, that came into existence. So as the land started folding beyond the Middle Himalayas, in certain small areas, in very small areas, what happened was that as the land started folding up, it blocked the path of these rivers. Okay, so as the path of the rivers were blocked because of the further folding, it did not happen across the entirety of the ranges. Only in certain areas you did experience that. So as a result of that, in these small areas, water started piling up. And you had significant amount of piled up water which was present. Okay. Now, this water which was piled up was basically nothing but the river flow. Slowly and steadily, water started accumulating in the valley, in these small valleys between the middle and the outer Himalayas or the Shivaliks. Now, eventually, as the amount of water started increasing, it exerted pressure as well, and eventually from the sides, the water emptied itself out. The water completely drained itself out. As a result of that, the entire water which was present, that drained itself. But what was left is the deposits that this accumulated water had carried. So these deposits, they occupied the portion. As the water emptied itself, the deposits, they remained. Right? And these fertile deposits, these were very fertile. These created a kind of a plain-like region in the valleys in between the mountains. So these were the deposits. Carried out as a result of the river water blocked in certain areas. Now, these deposits, they are basically in existence in between the Middle Himalayas and the Shivaliks. It is these deposits which we refer to as dunes or duars. If these deposits are to be found in the region of Western Himalayas, they are referred to as dunes. If the same deposits they are found in the region of the Eastern Himalayas, they are always referred to as duars. Okay, for example, Dehradun, Kotli Dun, Patli Dun, all these are names of various different dunes. If ever you happen to visit Dehradun, for example, you will observe when you, those of you who are from that place, you would easily identify with it. And those of you who have visited Dehradun, if you have actually observed the nature around Dehradun, you would also observe it, as long as you were not only concentrated with the shops nearby. If you happen to the landscape nearby, you observe in Dehradun that while the entire of Dehradun is across a plain, but from both the sides, it is almost surrounded by the mountains. So it is basically, imagine at one point of time, the other mountains of the Shivaliks would not have been present and the rivers would be draining from this area. I will repeat the entire process of formation. Okay, so listen to this carefully again. How is it that dunes and duars got created? When we talk about, let's say, dunes or duars, these are deposits which happened in the valley in between the Middle Himalayas and the Lesser Himalayas, or Middle Himalayas and the Outer Himalayas, that is the Shivaliks. So basically, the time span between the formation of the Middle Himalayas and the folding of the Shivaliks, that was a large time span. So you had multiple rivers which had already started to come into existence in this region. Many of those rivers don't even exist today, right? So those rivers, in certain small areas, they started observing a kind of a blockade, right? Why? Because the land in those areas started forming a kind of an obstruction due to a fold. Even though folding is a slow process, but then in certain areas, this folding managed to block these rivers. Eventually, water started accumulating. And these rivers, they would bring sediments, pebbles, everything along with them. So as the rivers, they started accumulating themselves, the deposits, they started planting themselves in that valley region. Eventually, as the water level increased in those areas, so you can always imagine, let's suppose you consider a hill or a mountain, eventually, as you go closer to the top, it becomes narrower, it becomes tapered. So water started flowing from the sides and emptied itself, eventually leaving behind those deposits, and those deposits are what we refer to as dunes in the region of Western Himalayas and duars in the region of Eastern Himalayas. Okay? Now, after this, when we talk about another kind of a feature that you generally associate with the region of southern slope of Shivalik, that is a feature which we refer to as chos. Now, what do we mean by chos? So when you talk about chos in existence, these are basically seasonal streams which drain down the southern slope of the Shivaliks, especially during the rainy season. We know that the landform of or the topography of all the different ranges exhibits a kind of a hogback characteristic, where the southern slope is much steeper as compared to the northern slope. So because the southern slope is much steeper, because the momentum, an increased flow, an increased speed and velocity of the streams which drain down the southern slope always. So as a consequence to it, we observe basically that these chos that we talk about during the rainy season, what happens is that you have, let's consider this as the southern slope. Let's consider this as the southern face of the Shivaliks. Right. Southern slope and northern slope, I hope you don't have a problem in associating with that. The slope of the mountain which faces the northern side is the northern slope. The slope of the mountain which faces the rest of the country, that is the southern slope. So here, during the rainy season, what happens? It is the southern slope where the winds will come, moisture-carrying winds will come. The winds will be forced to rise up. They will form very dense and thick clouds, and they will get significant amount of rainfall, right? So due to that increased rainfall which happens across the southern slope, you come across a scenario where multiple different seasonal streams, they emerge. Multiple different seasonal streams. And as these seasonal streams, they emerge, they end up eroding anything and everything which is in place in that region. They create numerous gullies due to the erosion that they carry out. These are seasonal streams, by the way. These are not rivers. They come into existence when you have excessive amount of rainfall. That is when they come into existence. But when they do come into existence, they erode the entirety of the landscape. So the southern slopes of the range of the Shivaliks are almost completely devoid of forest cover, especially in the range of Punjab and Himachal, and they are dissected severely by multiple seasonal streams, which are locally referred to as chos. Okay, these chos or seasonal streams, they carry out erosion. Significant amount of erosion. Okay, so they will always they are always generally observed immediately during or after the rainy season is when you observe them in significant proportion. This is something which is a characteristic of the Shivalik ranges only, not a characteristic of the middle or the Great Himalayas. Okay, now then another kind of landform whose formation is very similar to that of dunes and duars, but this is a landform which you find in the region of Jammu and Kashmir, that is Karewas. These are also deposits brought down by the rivers. So their formation and their existence, if you look at it, basically here, this is the entirety of the stretch where you will find these Karewas to be in existence. It is in many areas in between the Great Himalayas and the Pir Panjal, in many areas between the Zaskar and the Pir Panjal. So what happened was, here again, a similar process was repeated. You had the formation of the earlier mountain, and then eventually you had the smaller streams and rivers which would originate from that, but it was blocked by the emergence of the Pir Panjal range. Pir Panjal range. As a result of that, the water which was drained or water which was coming, that water occupied a large area, close to around 500 square kilometer and even more, right? That is how large an area it occupied. The water formed a very large lake of sorts. So this lake started increasing in terms of the water level because the water was continuously supplied by the smaller streams, by the smaller rivers. So the lake increasing in terms of the water level. At the same time, because you had this lake, you also had in existence the deposits which were carried out by this lake. So you had significant amount of deposits which were carried out. Eventually, as the water level increased, there the water started putting pressure on the landform, and you also had the existence of, by that point of time, you had the existence of Baramulla Gorge. I'm sure you would have heard about the name Baramulla. Very, very important in terms of the historical trade routes, very, very important in terms of passage of religious tourists, travelers across the ages. They would travel through Baramulla. So in Baramulla, you have a significant deeper gorge. So there, from the Baramulla Gorge, all the water eventually exited itself. And as the water exited itself, it left behind very fertile deposits. And these fertile deposits are what we refer to as Karewas. Right? These are also referred to as lacustrine deposits. Lacustrine deposits. What is meant by lacustrine deposits? Lacustrine refers to a kind of a deposit which is carried out by a lake. Right? That is what is referred to as a lacustrine deposit. Because you had a creation of a lake spanning across hundreds and thousands square kilometer in area, that is why this is referred to as a lacustrine deposit. Now here, in the case of dunes and duars, this was happening on a very small scale. This was happening across a scale of, let's say, a few square kilometers. Here, it is happening across a very large area. Now, these deposits, they are very fertile. Very fertile. In the region around Pulwama, in the region around Anantnag districts, that is where you still find these deposits in existence. Because they are very, very fertile, they are ideal for the growth of fruits. Fruits and fruit orchards. Other than this, in this region of Karewas, you also experience and observe the growth of one of the very significant and costly spice, so to say. Here, this is where saffron or saffron is cultivated in significant proportion. Saffron is cultivated in large proportion in this area. Okay, so that is where you will find this unique property of Karewas in existence. Okay, now after this, as we move higher up in the case of the middle Himalayas, beyond a particular height of around 3,000 meters, 2,500 meters and so on, you don't find the existence of permanent tree cover. You don't find the existence of large trees and forests, but rather you come across something which we refer to as the summer grasslands. That is, you will have very fertile grasslands or very lush green grasslands occurring in the region or occurring during the summer season. And again, during the winter season, the entire area is covered with thick and dense snow. So it is only during the summer season where you will come across these grasslands. These summer grasslands, they are referred to as bugyals. Okay, they grow only during the summer season. Now, these grasslands typically are utilized by many of, for example, these have become a hub of tourist attraction in a way that you will find almost all your friends who trek to the region of the middle Himalayas and so on. All of them, they will continuously show you that how lush green these areas are. the grasslands, etc. So that is basically the summer grassland. During winter, the entire area will be covered with snow. Again, during summer, the grasses will grow. So this is utilized by the traditional nomadic community. And when we say nomad, what do we mean by that? Nomadic communities are those historically who have indulged in translocating from one area to another in order to cater to the pastoral requirements of their cattle. So they take their cattle for rearing purposes, where the cattle, they graze on the green grasses, and again come the winter season, they will migrate away from these areas into another area where they find the grasses. So this entire nomadic community and the lifestyle is dependent upon the availability of green pastures, because you will find that these communities, they have hundreds of sheep, hundreds of goats, etc. So they do rely upon these bugyals for the survivability of the cattle community. Now, this entire process, this entire activity where they move up the slope of the mountains in order to graze their cattle and again come down the slope during the winter season in order to escape from the harsh conditions, this entire activity is what is referred to as transhumance. Bugyals are found in middle Himalayas at a greater height. Okay, this is what is referred to as transhumance. Now, this is carried out by various different nomadic groups. For example, you have the Bhotias, they carry it out. Then you have the Bakarwals. Then you have the Gaddis. Then you have the Gujars and the Bhotias we have already looked at. So these are the major communities which carry out the process of transhumance. What is this transhumance? Transhumance is that process whereby these nomadic communities, they move up the slope during the summer season in order for their cattle to graze upon these green grasses. Again, come the winter season, all of them, they retreat back to the slope into the lower areas in order to escape the harsh winter conditions. So that is the transhumance activity. These are the nomadic communities which carry out this process. Nomadic communities. Okay. So Karewas, basically Pavithiran again has been created in a similar process as compared to the dunes and duars. Just the difference is that Karewa formation has happened across a large area, where in the case of dunes and duars, we saw that the Shivaliks, they offered a kind of an obstruction. In this case, it was the Pir Panjal range which got created. And as a result of that, a very giant and large lake spanning across hundreds of square kilometers, that came into existence. In that lake, you had deposits which happened in the meanwhile. Eventually, as the water level increased, all that water exited itself through the Baramulla Gorge and furthermore into the region of Arabian Sea. But what was left behind was very fertile lacustrine deposits, which we refer to as Karewas. Okay? Baramulla Gorge is in Baramulla, right? And I know it appears to be a very simple answer, but Baramulla Gorge is basically, locate Baramulla first of all in the map. And Baramulla is a very vital region, very important area historically as well, and a very sensitive area when it comes to the border management even today. So Baramulla is something you should be aware of. Locate it on the atlas. It is there that a gorge has been created. Okay. Now, when we come to the eastern part of these hills, in the eastern portion, you hills created significantly in the region of Arunachal You have the Dafla, Miri, Mishmi, and Ebor. These are the ones which get created in the region of the eastern. It is across the eastern side where you have the Namcha Barwa range. Himalayas, they take a syntaxial bend from the region of Namcha Barwa. Himalayas take a syntaxial bend from Namcha Barwa. Their axis changes, their direction changes. It is across this Namcha Barwa itself where you will observe that even the mightiest of the mighty rivers, that is Brahmaputra takes a sudden southward bend across this region of Namcha Barwa. Now, across the east, mountains which have happened as a result of the collision of the Indian landmass with the minor Burmese plate. So across the side of the Burma and the Myanmar region, you have the formation of Arakan Yoma, Pegu Yoma, Tanasarim, these mountain ranges. Across the Indian side, you have the Patkai Bum, you have the Naga Hills, you have the Mizo, or what are also referred to as the Lushai Hills. Here you have Mikir and Barel ranges in existence in the region around the area of Assam. Here you have the Mikir and the Barel ranges as well. Okay. Now, Garo, Khasi and Jayantia, they are not a part of Himalayas. Garo, Khasi and Jayantia, they are significantly a part of what? They are a part of Peninsular Plateau. Okay. Part of Peninsular Plateau. Right? Now, this is basically the portion in the eastern part of the Himalayas. Now, this here in the region of the Naga Hills, Patkai Bum, Lushai ranges, etc., you will find that there are multiple passes which provide people to connect between Myanmar and the northeastern regions. So that is where you have many passes in India, Pangsao Pass, etc., which provides a people interchange in this area. Now, before moving on, portion regarding this, that is, I'm sure you would be aware of it, that why Himalayas experience frequent landslides. Why do the Himalayas, they experience frequent landslides? So first of all, the first reason, unstable mass where the slope or where the height is still increasing. Okay. Why this unstable landmass? Because of the tectonic activities and the movement of Indian plate towards the Eurasian landmass. Then you have frequent seismic activities which loosens the materials which slide down. Then after that, very steep slope. So the gravitational component of it will be more, right? Without going into the mg sine theta and mg cos theta of it. So just understand that if the slope is very significant, materials tend to fall down easily. If the slope is, let's say, slightly gradual, the materials will slide down easier. Where if it is very steep, materials will start sliding very significantly. Then you have huge concentrated rainfall in which slope? In the southern slope. Right? In very steep slope, please add hogback topography. Okay? Then after that, you have the factor that when you have the concentrated frequent disasters such as cloudbursts, and flash floods. Right? Frequent disasters such as cloudbursts and flash floods, they will carry the materials along with them, and that will lead to landslide again. Then you have a general lack of vegetation. Then you have unscientific and unsustainable construction activities. What it does, it basically weakens the slope, right? Then you have in the eastern part, you have mining activities which make the slope unstable. Right? General lack of vegetation can be attributed to many factors, by the way. When we talk about a general lack of vegetation, very steep slope, it can also be attributed to, let's say, lack of deep soil cover. It can also be attributed to overgrazing by the pastoral nomads. All that can be attributed. Deforestation, which is also happening at a massive scale in the region of the northeastern states. So that also you can add in the general lack of vegetation. Okay? Seismic activities means earthquakes. Right. Now, these are basically the different features or the different reasons. 1, 2, 3, 4, 5, 6, 7, 8. Right? Here in construction activities, you can talk about tourism, where you have, let's say, resorts, tourism, and also infrastructure. Okay? If there is a lack of vegetation, there won't be much to hold on to the soil. So the soil will simply move down. So you have 8 points here, guys. Even in all these points, if you manage to write only around, let's say, 20 words out there, that also takes it to 160 words. But I'm sure in many of these, you will be able to craft more than 20 words out there, right? So this is something which was asked in UPSC in the mains exam, has been asked repeatedly in UPSC in the mains examination, okay? So that is something which you should be ready with, okay? Now, then we come across to the southern part, that is the northern plains, southern part of the Himalayas, that is the northern plains. Now, northern plains, they represent one of the most fertile landscapes that you come across in the entirety of the region, in the entirety of the zone. In fact, northern plains, they are estimated to be one of the most fertile tracts in the entire subcontinent, if you consider it. Now, for the formation of northern plains, geologists have been pondering for many, many years, many decades, that how these northern plains came into existence. Because it was found out that in many areas, the depth of the sediments that forms the northern plains, the depth is more than 2 kilometers in certain areas. And that puzzled everybody. Because the very basic understanding, a very basic logical application, if you will do, that how is it that you have sediments to the south of the mountains or at the foothills of the mountains? The easiest explanation will be that, look, rivers are bringing down the sediments. Now, if the rivers are bringing down the sediments, they will deposit it. And that is why the plains are created. But then, why do they have so much depth? If the condition would have been, let's say, a condition like mountain and the river draining the sediments, these sediments would have accumulated like this. Why is it that it has got a depth significantly? So that is where many of them had various different types of theories about the rivers coming into this area, etc. The most acceptable theory was provided by the Austrian geographer, the geologist that we have already talked about, that is Edward Suess. Edward Suess, right? You had Edward Suess, who provided the concept of four deep. Now, what is this 4 deep? So here, RE is a different term, deep is a different term. 4 means what? Something which is ahead of it, right? Something which lies before. That is what is the meaning of 4. And deep. So as per Edward Suess, that as the Indian plate started colliding, and I will take the help of the almighty tissue paper to help us understand this. As basically you had the entirety of the Indian plate colliding with the Eurasian landmass, while there was upfolding which created the mountains, but then simultaneously whenever there is a kind of an upfolding, there is also a downfolding. Right? Whenever there is an anticline, there will be a syncline which will get created simultaneously. Rarely will you come across a situation where only upfolding has happened, nothing else. So whenever you have an upfolding, in front of it, if you observe, you have a downfolded region as well. So this is where it is said and it is estimated that when you had the Indian plate which underwent a collision, while there was a significant upfolding which created the Himalayas, simultaneously, it was limited up till a certain region. Up till where? Up till the hard rocks of the Peninsular plateau. You had the hard rocks of Peninsular plateau. So as a result of that, you had a kind of a downfold which happened before that. These hard rocks could not be downfolded. Now here, the rivers draining from the mountains, they continue to drain in that region. In fact, one of the theories, those of you who will study it for optional, you will study it, that one of the theories also talks about the fact that at one point of time, you had river Ganga as well as river Brahmaputra, which did not drain into the Bay of Bengal, but for a significant portion of time, they kept on accumulating in this area. Nonetheless, these rivers, when they came, that is the mighty river Ganga, the river Brahmaputra, as well as the Indus River basin, all of them, they started depositing sediments in between here. Right? This was the four deep. This was the four deep. And why this downfolding happened? Because of the aspect of maintaining balance, that if an area gets upfolded, in order to maintain balance, there will be a kind of a downfold as well. So that is where you had the formation of a four deep, which was filled with sedimentary deposits. Sediments brought down by the Himalayan rivers. Okay. Now, this is basically the aspect of the formation of the northern plains. But when we talk about the northern plains, it is not as if it is homogeneous. It is not as if from the foothills of the Himalayas to the portion near the Peninsular River or the Peninsular plateau, it is not as if you will find the similar conditions in existence. You find different conditions in existence, different types of materials which get deposited. Few of the materials, they were deposited long time back. And that is where those deposits, they indicate a different texture, different grain size of the sand particles. Whereas in few of the regions very close to where the river is moving, you'll find that the deposits happen every year. So that is where the soil is also very fertile. Those of you who have ever, let's say, been to a river, right, for any purpose, for any other related purpose, if you have been to a river, you will find that as you are far away from the river, as you are distant away from the river, the grain size of the soil particles, they are larger. Right? The soil particles, they are larger in size. Individual particles are larger in size. As you come closer to the riverbed, you will find that the particles are absolutely powdery. They are very, very smooth. They are very, very small. So even the northern plains, from the foothills of the Himalayas to the southern extent, they have a kind of a division in terms of what kind of materials are constituted or composed in that area. Right? So let us take a look at these northern plains as well. So when we say the northern plains, they are formed by the alluvial deposits brought by the Indo-Brahm rivers, or basically the rivers of Indus, Ganga, and the Brahmaputra. Now, these northern plains, they extend for close to around 3,200 kilometers from west to east or east to west. Their average width varies between 150 to kilometers. However, the northern plains, where are they widest? They are widest in the west. They are widest in the western part. And they are narrowest where? If you observe the map of the country, you will observe that in the region of eastern part of Jharkhand, West Bengal, that is where you have the Rajmahal Hills. That is where the northern plains are narrowest. Narrowest in the eastern part. Near Rajmahal Hills. Okay, so that is where the foredeep was created, and that is where it was eventually filled. Now this foredeep, that was created in the entirety of the stretch, all the way from the region of the present day region of Pakistan, the northeastern portion of Pakistan, all the way up all the way up to Assam. So that entire area, that had a kind of a depression, what is also referred to as a syncline, a geosyncline, that was created. Why? Because as the land collided, while some portion got uplifted, the other portion immediately close to it, that experienced a depression, and that depression later got filled with the fertile materials and sediments brought down by the rivers, and that is what we refer to as the fertile tract of these northern plains. Okay? Now, as I said, when you move from the foothills of the Himalayas into the northern plains, it is not a kind of a homogeneous characteristic. It is not a kind of a homogeneous tract. You have various different types of them. So when we talk about it, basically, you have immediately at the foothills, you have Bhabar, Torai, then you have Bhangar, and then you have Khadar in between. So let us try to understand how these get created and what is the individual property of it. So if we take a look at it, initially, let us assume that you have a large river, or rather, let's start with a mountain. Now, as the river comes down a mountain with significant amount, or a hill with a significant amount of, let's say, velocity, that river will be able to carry large amount of stones, larger boulders, rock pieces, etc. Everything will be carried by this river, isn't it? But then, as soon as it enters the plain area, right, I'll show you the cross-sectional view as well. So let's suppose you have this mountain and you have a river which is coming down the slope. Now, as it comes to the plains, the speed reduces. So all the heavier rocks, the larger rock particles, boulders, etc., that the river was carrying, where will those go? They will start getting deposited here. Right? All those larger rock pieces, boulders, etc., they will start getting deposited here on top of each other. That is where they will eventually get deposited. They will keep on getting deposited on top of each other. Now, as they get deposited continuously, eventually this forms a kind of a rocky terrain of sorts, where from top, if you will look at it, from top, the river won't even be visible. The view of the river will be blocked by the different stones and rocks which have been brought by the river. Okay. This is a region which you refer to as the harbor. This is what you refer to as harbor. Now it consists of various different rocky. Now you can logically think about it, that if you of Bhabar here, now can this be suitable for culture? Can agriculture be carried out in this area ideally? Absolutely no, right? So this area is absolutely unsuitable for any amount of cultivation. Cultural activities can be carried out in this region. Having said that, you do find the individual appearance of trees here and there in isolated proportion, but most of these areas is barren almost. You have, and if you do happen to go to this area, you will hear the large and the very loud gurgling and the turbulent noise of the river, but you won't be able to see the river because the river on top of it, you will have so many stones deposited that the view of the river will be blocked. So it oftentimes presents a very dangerous scenario, a kind of a scary scenario when you do visit these areas, especially at night. So if you do want to, for example, if you ever do visit any Himalayan region for trekking purposes, the easiest one that you can reach out is in the region around Rishikesh. So if you do happen to trek to the north of Rishikesh, or if you do happen to travel through the north of Rishikesh, you will find significant amount of these deposits, as far as even up till the plain areas of Haridwar. Even if you come to Haridwar, and if you observe river Ganga in between Rishikesh and Haridwar, the river Ganga on its sides would have deposited large stones, large boulders. So that is what constitutes the Bhabar tract. Okay? Now, after this, when we talk about it, after the coming out of the region of Bhabar, here, the river, it comes out. The river as it comes out. The river then comes across a region where it does not move in a kind of a predefined channel or a predefined stream, but it flows wherever it gets the opportunity to flow. It flows in whichever area, in whichever direction the slope leads it to. So it won't have a well-defined stream or a channel. But then it will flow across multiple small channels. Eventually, all these channels will then unite to form the larger river flow. Right? They will all unite to form a very, very thick and a very broad river flow eventually in the plains. But then in this area, the river flows in multiple small channels, multiple small diversions. And this is the area where, due to excess supply of water moving in random directions, the soil becomes very muddy and marshy in characteristic. So in this area, you will have the soil, which turns marshy and muddy. And this is the region which is referred to as the belt. Now, basically, very and also, due to excess supply of water, this is very, very fertile. So as a result of which, agriculture can be carried out very easily. Other than that, significantly huge natural vegetation in the form of deciduous forest and very dense forest is something that you find in the region of the Tarai belt. So this Tarai belt is very rich in biodiversity. Since the Britishers, they came into our lives, the biodiversity has reduced. But basically, this has been a tract which historically has been housing significant population of tigers, elephants, as well as one-horned rhinos. Many of them, they found their natural habitat in this region. In fact, even today, if you look at, for example, part of Rajaji National Park, part of Corbett Tiger Reserve, both of them are situated in this Tarai belt. Okay? Now, here, after the Tarai region, that is when the river starts to flow in its broad channel, in its broad region again. Now, as it starts, something which has been carried out for a very, very long period of time, for a very long span of time. So there would have been earlier deposits which would have happened, maybe floods which would have occurred. So you have older deposits which have been carried out far away from the river, present day river, and you have newer deposits which are being carried out by the river on an yearly, monthly, or a daily basis. I will repeat. When the river moves in the plains, the rivers basically, they have been in existence for many millions of years, right? So, he deposits very far away from the course. These deposits, they have been carried out long time back. Okay, these are what are older deposits. These older deposits, if you will find, they are less fertile. They are less fertile. Then these deposits, if you will find, the particle size of soil particles is larger. Why is the size of soil particle going to be larger? Understand this carefully. When you have, let's say, deposits happening in a region, let's assume you have significant amount of deposits happening in this area. Lot of deposits happening in this area. And here the deposits have been happening for, let's say, 15 million years or 5 million years. Right? Now, the materials at top, the particles at top, they will have their own individual weight. Fair enough? They will have their own individual weight. So they will exert the weight on the lower levels. Now, the lower particles, they will experience a kind of an overwhelming weight. Now, this weight is which is exerted is not for a temporary duration. It has been thousands of years. So, they get compressed. When they get compressed, they start secreting amount of liquid minerals which is in them. For example, the sediments brought by the river, they are typically rich in calcium. So that is when, due to the overwhelming weight on top, they start secreting some amount of calcium. Now, due to calcium has got very good binding property. Now, due to that calcium, few of the compressed particles, they start sticking together. They come together and eventually they will form one larger calcareous concretion. So this is how in the older alluvium, you have, due to the huge overlying weight, you have calcium concretions, and these calcium concretions, they are referred to as conchers. Alluvium is basically the fine particles which are brought out by the river, which are deposited by the river. That is basically alluvium. The fresher sediments will also include calcium, but they have not yet got enough amount of time to carry out the binding property. Eventually, have you ever thought that when we talked about the portion of the sedimentary rocks, have you ever thought to yourself that how is it that sediments eventually turn into a hard rock? How can that be possible? The same principle is at play, where if you have significant amount of sediments, one on top of each other, they will exert a weight, they will start compressing. As this compression happens due to that weight, the lower areas, they will start secreting any liquid amount, and even in smallest milliliters that they can, liquid particles or liquid minerals, they will start secreting. They will start binding the particles together. That is how you have the formation of larger calcareous particles. Okay, so this is the older deposit. This older deposit, it is what we refer to as bhangar. Calcium, how is it present in these materials? So these materials brought down by the rivers from the mountains, they include various different minerals, including calcium, magnesium, potassium, sulfate, chloride, sodium. They do include all these components. Okay. Now, the river, meanwhile, why is it that the older deposits have happened so far away? Because it might have happened long time back in history that there would have been an overwhelming flood like the flood that we received right now in Pakistan. Now in Pakistan, the floods which occurred recently, the entire districts, they were covered in water. So imagine the river is flowing in this path, but it has flooded the entire district because of huge amount of water flow. Now, wherever the water would have flooded the region, there would have been some deposits happening here and there. So as a result of that, those deposits will remain in that place if left undisturbed, and the river will come back to its original position. These floods, they don't occur daily, do they? They occur maybe once every 100 years, once every 1,000 years, and so on. So it is during these incidences and events that older deposits, they get carried out. In much of the region around Sindh region of Pakistan, you will find large tracts of these older deposits. In India, you will find these older deposits in the southern part of Uttar Pradesh, particularly in the region around Bundelkhand. You will also find them to be in existence partially in the region around Haryana. You will also find them to be in existence partially around Bihar as well. Then furthermore, the river, when it moves, it carries out fresher deposits of very fine particles very close to the flow of the river. Very fine particles, they keep on getting deposited very close to the river. These are the newer deposits. These get replenished almost every season, almost every year. So these finer deposits, these are newer deposits. They are very fertile. Then very fine-grained. Fine-grained basically brings about a unique ability to the soil to hold water and moisture together. If the soil, if ever you have basically seen a desert or a very sandy soil, basically if you put water in it, water will simply drain away. But if you have a very fine-grained, powdery kind of soil, you put some water, it will hold that water. Air also it will hold. So if the soil has very fine grains, it has got that unique ability to hold air and water. And that provides very significant fertility levels to the soil, where the soil has got the ability to support the growth of the plants to significant extent. This newer deposit, this is what is referred to as khadar. Okay, so that is how, when you come from the northern part of the northern plains, that is the foothills of the Himalayas, into the deeper portion of the northern plains, you will find various different subclassifications. So obviously, khadar is the one which is most fertile. Bhangar is also utilized for growing certain crops which don't require very fertile soil. For example, you can grow maize, you can grow millets, jowar, bajra, ragi. You can grow basically pulses. All these you can grow in the bhangar soil. But every other crop you can grow in the khadar soil. Khadar is the one which will support any and every kind of crop. Okay? Now, one by one, when we say the Bhabar. So a narrow belt of 8 to 10 kilometers parallel to the Shivalik foothills. The rivers disappear in this zone as the rivers deposit heavy boulders. They deposit heavy boulders, right? So it appears as the river in itself is not visible because that visibility is blocked by the stones and the rocks and the boulders which are present. The area is not suitable for agriculture, but you will find few trees here and there in existence. Okay. Now, the Tarai, it is to the south of Bhabar. The approximate width is around 10 to 20 kilometers. Streams of the rivers, they re-emerge here, and because they have been hidden for a long time under these Bhabar. So when they re-emerge, they don't have a unique or a fixated channel which they can follow. So that is why the river diverges itself, diversifies itself into multiple smaller channels. It makes the soil marshy and muddy, but at the same time, these conditions make natural vegetation very prominent. And that is why in that entire Tarai belt, you will have very dense natural vegetation. In fact, next time when you read medieval history, I want you to pay significant attention when you are reading the Delhi Sultanate, right? Even from the basic NCERT books which you study, you'll find that when you had Balban, who became an emperor during Delhi Sultanate, at that point of time, he ordered massive deforestation of the Tarai belt in order to stop the robberies which would happen in that area. So historically, Tarai belt always has been very significantly and densely forested. So historically, that much deforestation could not happen in hundreds of years, what the Britishers managed to achieve within a one or a couple century. Okay, now, luxurious growth of natural vegetation and basically houses of varied wildlife. Okay. Now, which wildlife are we talking about here? We are talking about basically amongst the larger animals, tigers, elephants, one-horned rhino. Even today in the Tarai belt, you do find these three. Okay. Now, the alluvial plains divided into Khadar and Bhangar. Khadar is the newer alluvium, Bhangar is the older alluvium. In Khadar, the fertility is much more, gets replenished every year. Bhangar is the older alluvium which has been deposited long time back. Okay? Now, here, the terraces, that is as you move towards the older deposits there, oftentimes the Bhangar is impregnated with calcareous concretions, which in local language is also referred to as kankars, right? You would hear those of you who have, or let's say, go to your nearby kirana shop or your nearby ration shop or a grocery shop, you would find that when they give out certain grains, you will have larger pebbles in them. They refer to them as kankars. So that is where the kankars, they come from, right? They come right at the time of harvesting of the crops. These larger concretions, they come along with the grains of rice and wheat. And that is what you have even in your domestic household. Even now, I don't know what is the situation. Even today, in many areas, you find that before cooking anything, you sieve through the grains in order to see if it is present or if the kankars are present or not. So that is where the kankars, they come from. Okay? Kankars, they are going to be rich only in terms of calcium. Right? Bhabar is unfit for vegetation because it has large boulders and large stones. In Tarai, you have very fertile soil as well as you have lot of availability of water. That is why. Bhangar is basically made by the older deposits which have happened maybe 100 years back, maybe 500 years back, 1,000 years back. Since then, newer deposits have not happened. That is how Bhangar is made. Okay. Kankars, they are present under the surface, but eventually when you till the soil, when you carry out the cultivation, it always can come to the surface. They are not, no, conchers are not edible. Right? Now comes the portion of Indian desert. See, all those of you who are finding this portion as difficult, it is only because we are making it difficult. Ideally, if we had to cover it just like it is covered everywhere, and for general studies, how it is generally covered, when you open up the NCERT, you will find it to be very easy, right? Where you will find that the Himalayas, they are divided into Great Himalayas, Middle Himalayas, Newer Himalayas, or rather the Shivaliks, then the portion in the region of Jammu Kashmir, Jammu Himalayas, the portion in the region of Uttarakhand, Uttarakhand Himalayas. Then you have the northern plains. They are named as the way Punjab plains. They are named as Rohilkhand plains. You just go for the naming of it, ideally. The only reason you might find it a bit difficult is because we are going behind the process of formation of it. Again, I would say that if you find it incomprehensible, don't bother yourself about the formation process. Just concern yourself with the basic aspect. What are northern plains? What do we mean by Bhabar? What do we mean by, let's say, conquers? What is the definition of Khadar, etc.? More than sufficient for your general studies. Okay? So those of you who are saying that this is very, very difficult, please. And if you say that world geography was much easier than Indian geography, clearly you have not explored world geography significantly. Okay? Now, the Indian desert, which is also in the western part referred to as Marustali, the Thar desert. Now, this Indian desert, it extends in the region of the western part of Rajasthan to the west of the Aravalis. Right, to the west of Aravalis. Now here, at one point of time, this was not a desert. It has been formed as a desert very, very recently. Right? Very recently, again, in geographical terms, that is a few thousand years back. A few million years back. So not very recently in terms of historical time scale, recently in terms of geographical time scale. So here, this had never been a desert. In fact, at one point of time, there was a shallow sea which existed here. You had water body which existed here. That is the reason why you do find significant amount of oil and natural gas deposits, particularly in the Shekhawati region of this Thar desert. But this Thar desert has become a desert because of the new position of the Indian landmass and the Indian plate. As Indian plate detached itself from the Gondwana land in the southern hemisphere and started moving north, this particular region would receive ample amount of convectional rainfall. In fact, it is said that when the collision with the Eurasian plate was happening, some part of Tethys Sea even entered this area. In the very initial days, this area of the present-day Thar desert, that was very fertile plain. Because the Aravalis, at that point of time, the Aravalis are the oldest fold, one of the oldest fold mountains in the entirety of the world. These Aravalis, they got created long before any other mountain that you can think of. At the point of time when the crust in itself was significantly softer. So at that point of time, Aravalis, they were so very tall that evidences point out that you had massive glaciers which would originate in the region of the Aravalis. But as is the case of the nature, everything which initially comes into existence, which is magnificent, eventually will be returned to the ground. Once the upliftment and the folding of the Aravalis stopped, the degradation, the weathering, and the mass movement was initiated. And now the Aravalis are nothing but a remnant of what they once were. So at one point of time when they were so massive, you had large rivers which would drain this area and they would deposit the sediments which initially had formed this region. But then why is it that presently it is a desert? Presently it is a desert because of the orientation or the alignment of the Aravallis. Alignment of Aravallis. What do we mean by that? So if you look at the direction that the Aravalli ranges are in, these Aravalli ranges, which to some extent they extend even up till the region of Delhi. And in fact, it is said that some part of it extends even up till the Delhi-Haridwar ridge. That is also said to be a part of the earlier Aravallis. So at one point of time, imagine the Aravallis would have extended all the way to this massive chain. But as of now, they are present only here. Now, the Aravallis, due to their alignment, means what? It means that you have the Arabian Sea branch of monsoon running parallel to it, right? Thereby causing rains in the region of Punjab, Himachal, Haryana, and so on. Had the Aravalli mountains been in an east to west direction, they would have blocked the flow of the Arabian Sea branch of monsoon, and this region would have received rainfall. But then Punjab and Haryana would have lied on the leeward side of the Aravallis, and Punjab and Haryana would have been a desert in that case. Then the Aravallis, they block the Bay of Bengal branch of monsoon, which causes significant amount of rainfall or some amount of rainfall on the eastern margins of Rajasthan. Right? So this is why the western portion of Rajasthan is a desert. Okay? So alignment of Aravallis basically southwest to northeast direction. Now, as a result of this, Arabian Sea branch of monsoon, Arabian Sea branch moves parallel to it, parallel to Aravallis, without causing rains. And then you have Bay of Bengal branch brings rain in the eastern part. In eastern part. Okay? That is why it is said that had Aravallis been in any shape, any direction other than the present shape, Rajasthan would not have been a desert. But then the grain bowls of India, that is Punjab, that is Haryana, they would have been a desert. So that is why there is a very famous old saying that in geography, there is a very old saying that Rajasthan sacrifices itself for the greenery in Punjab and Haryana. Even though it is not as if something has been done deliberately, but that is how you tend to romanticize the entire, even the landforms, you tend to romanticize it. So that is the aspect of it. Okay? Now, here, when we talk about the Indian desert, it lies to the northwest of the Aravalli Hills. It is a land of undulating topography, dotted with longitudinal dunes and barchans. Barchans, we have already seen a kind of a crescent-shaped dune in existence. So, low rainfall below 15 centimeter per year. This is also what is referred to as Marusthali. Now, it is a kind of a desertified land where you have yadangs, mushroom rocks, and some oases here and there, but otherwise it is a vast, expansive desert. Okay? Now, after this, we come to the portion of peninsular plateau. Here, just I'll provide you the glimpse of it, okay? And we'll build up on that in the next session. Arid climate is a dry climate. How is oasis formed? Oasis is formed when you have basically the top of the sand getting eroded. So a depression is created where in certain areas the groundwater seeps out. That creates a kind of a water pool in between of the desert. Okay. Shakti, absolutely. Himalayas will also degrade once the collision stops, once the upliftment stops. We will come to ephemeral river. So, let me give you a brief glimpse about the Peninsular Plateau. The Plateau is the oldest landmass that we have in India. Not only in India, it is said it is amongst the oldest landmass across the entirety of the globe. This Peninsular Plateau has a volcanic origin. That is, it has been created as a result of the cooling down of molten lava. That is why it is very, very rich in igneous and the metamorphic rocks. That is what you find in significant quantities, in significant proportion in the region of the Peninsular Plateau. Now, over a span of billions of years, here we are no longer in the talk of millions. When we come to Peninsular Plateau, we talk in terms of billions of years. That is how old this is. So over a span of billions of years, this region has undergone multiple changes. The rocks have actually undergone through multiple different rock cycles, where the igneous rocks have been in existence. Those igneous rocks have been eroded by the rivers. Those sediments have been deposited in various places, forming sedimentary rocks in certain portions, such as the Kadapa region around Andhra Pradesh. Many of the sedimentary rocks have then metamorphosed, forming metamorphic rocks. Many of the igneous rocks, they themselves have metamorphosed to form metamorphic rocks. But nonetheless, one thing which has remained consistent over this large time span has been the natural process of degradation and erosion. Now, due to that continuous process of weathering and erosion, the top surface of those lava deposits, they have been removed. And now we are left with the bottom portions. And that is why all the regions in the Peninsular Plateau, they are very, very rich, very well endowed when it comes to the portion of mineral deposits. That is why in all these areas, you'll find significant amount of deposits of iron. You will find deposits of, let's say, even gold, diamond, all these deposits, copper. You find these deposits in these areas because these are very old. In newer areas, you don't find many deposits in existence. In the older areas, that is where you get significant amount of deposits which come into existence. Now, how were they created? How did the Peninsular Plateau come into existence? How is a landform created? When you look at the map of India, if ever you think about the fact that how the entire portion of India got created, what is the first thing that comes to your mind? That maybe God created or God had so much of good wishes flowing around. That is how India took a beautiful shape. Is it? Landform always gets created in bits and pieces, small bits and pieces. You have very small land parts which initially get created as a result of volcanic eruption. Now, at one point of time, we have talked that the entire globe was covered with water. So you had land masses which started erupting and emerging out of it. Amongst one of those which got created the earliest was a small land mass in this area, around Chota Nagpur Plateau, present-day Chota Nagpur Plateau. It is said, and the recent evidences of the rocks and the study of the rocks, they indicate that at one point of time, around 3.2 billion years back, this was a region which had sandy beaches all around it. So imagine, that is how individual land masses, they get created. Then you had the creation simultaneously of another land mass here. That was the Bastar Plateau. You had simultaneous creation of volcanic landmass here as well. That was the Karnataka plateau. You had a creation of a smaller landmass here as well. That was the Bundelkhand region. You had a creation of a landmass which immediately after forming had a movement due to which folding happened, and that created the Aravalis. Right? These were formed independently and individually. These small building blocks of land, they are also what are referred to as cratons. They are referred to as cratons. These are basically the Chota Nagpur craton, the Bastar craton, the Karnataka Plateau craton, Bundelkhand craton, and the Aravali craton. These came together. How? So they started moving towards each other. In fact, when the Bastar craton and the Chota Nagpur craton, they collided, you had the formation of a fold mountain in that region, which present day is just a small hill, which we refer to as Garjat Hills. You had multiple rivers which would originate from this area. They would start depositing, and the entire area had a kind of a continuity which came into existence. This continuity actually extended all the way till the region of Garo, Khasi, Jayantia as well. It was at that point of time that even Garo, Khasi, and Jayantia were formed. And this we get to know by studying the geological history of these particular rocks, where we get to understand that they have a same geological history as compared to that of the rest of the Peninsular Plateau, which means they would have been formed together. So that is how, at one point of time, you had a Peninsular Plateau, which actually was still very much part of the Gondwana land in the southern hemisphere, which extended from the Aravalis in the west all the way till the Garo, Khasi, and Jayantia in the east, which extended from the region of Bundelkhand in the north and the Aravali hills all the way up till Delhi to the region of the Karnataka Plateau in the south. Much portion of that Peninsular Plateau is underwater as of now. But then, during the process when the land got separated to the process when India came into its present position, India, for a brief moment, it lied over the region of Reunion Islands. Now, what is the specific feature of Reunion Islands which we find in Indian Ocean? Let me see. Good. You have hotspots. You have the presence of volcanic hotspots. So during that point of time, during that span of time, for a few million years, when the western part of India was lying over that Reunion Island hotspot, massive volcanic eruption happened. It is estimated that close to around 1.5 lakh kilometer cube of molten materials, they erupted. They started depositing themselves layer upon layer upon layer. And they started depositing themselves in this region. As they deposited themselves one layer after another, that is when, on the sides, they formed a kind of a step-like formation. This step-like formation is where the term trepin was used. And it is from this term trepin that you have the derivation, that is Deccan traps. Okay, so that is how the entire Peninsular Plateau got created. We'll carry on from this again in the coming week. Till that point of time, have a good weekend, relax, enjoy, and I hope that you had a kind of a meaningful session today. See you again on Monday. Till that, due to the lower latitude, so it will again form a cold ocean current. And that is what completes the entirety of the circulation. I will repeat again. So here you have the south equatorial current. After hitting the region around Cape Verde, after hitting the region around the Brazilian coastline, it will divert to the left that is where, induced by the Coriolis force, you have the Brazilian current. That Brazilian current very slightly so interacts with the Falkland current. It doesn't have a much greater interaction because the Brazilian current continuously will bend to the left, whereas the Falkland current also, which is a leftward bend of the west wind drift, it moves very closer to the coastline. Now, that Brazilian current will then be subsumed by the west wind drift here, and that west wind drift, after some distance, will again divert to the left Coriolis force, and that will be the cold belt, and the entire circulation will be completed. At the equatorial region, does the rainfall increase the volume of ocean? No, not significantly, very minorly. It is the insolation which will increase the volume. Okay, understand? Chandrasekhar, but in South Antarctic polar side, as easterlies due to the Coriolis force, then how western side wind form? So easterlies, the polar easterlies that you are referring to, that will be at further higher latitude. That will be driven much closer to Antarctica. We are talking about the region higher up as compared to Antarctica. So here you will have the dominance of the westerlies. Why winds from equatorial regions to Gulf Stream become warm? Winds? Are we talking about the winds, or Yashi, are you talking about the currents? The currents are warm because they carry warm water from lower latitude to higher latitude. Hence, they are warm current. Okay? Right? Now, this is about the Atlantic Ocean. Then, when we talk about the Pacific Ocean, a very similar approach is observed. You have put the correct question now. Cold currents flow from polar regions, travel towards the equator. They flow in clockwise direction in the northern hemisphere. So here you would have had the statement or the framing of the question as, consider the following statements about ocean currents, and then you would have these particular statements, Mega, if I am not wrong. So cold currents generally move that. Right? Is that understood? Mega. Or is there a doubt which came? Okay. Why west wind drift is not affected by Coriolis force? It is affected by Coriolis force. Observe in the case of the Atlantic Ocean, here also you have a movement. So here, and Mega, you had a doubt about the cold currents. Observe the cold currents. The cold currents in the northern hemisphere, they will be moving from the polar region towards the equatorial region. But what is the general direction of motion of the ocean current in the northern hemisphere? It is clockwise, right? In the southern hemisphere, it is counterclockwise, right? Why then Labrador current is anti-clockwise? Labrador current is not anti-clockwise. Labrador current is induced due to the polar easterlies. That induces a motion here. And then Labrador current, you will observe, it simply sticks to the coastline. Shape of the coastline is what determines the East Greenland current, the Labrador current, the Falkland current. They are all driven by the shape of the coastline. Okay. Right? Now, then we come to the portion of the Pacific Ocean. Now, in the Pacific Ocean also, you will have a kind of a similar principle where you will observe that due to bulging of water around the region of equator, after that it is carried in the westward direction due to the movement of the trade winds. Here you will have the movement of the trade winds. Here you have the movement of the trade winds. Now these trade winds, they will be acting both in the northern as well as in the southern hemisphere. Vivek, observe this particular aspect. You will understand that. The question that you have, observe this particular explanation, your question will be solved. So here, the trade winds, they will exist both in the northern and the southern hemisphere. Both of them will be moving from a direction of east to west. So that is where you will have the north equatorial current. You will also have the south equatorial current.
okay, north equatorial and south equatorial current, while induced by the shape of the coastline, the islands which are present here and the Australian coastline here. Other than that, you will have the currents being split into two. That is, the north portion will be driven further in the rightward bend as well, and then they will be driven further north. And here will be some amount of accumulated water which will roll back as a result of the rotation of the planet from the direction of west to east, which also induces a kind of a weak wind, which we refer to as the equatorial westerlies. That weak wind is also initiated by the continuous and fast rotation of the planet in the direction of west to east. So think about it. A surface is rotating continuously from west to east. So any object which is present here will also, in a way, follow that
কি
motion.
করবো তোমরা
So
বলো
that is the
খাবা না
reason behind the movement of the counter equatorial current, which sometimes also generates a equatorial westerly wind purely at the region of equator. Nonetheless, this north equatorial current here, basically, it moves just like in the case of the Atlantic Ocean. It moves here and it gets divided by the islands around Japan. And here you have the, towards the western part, you have the Tsushima current, and towards the eastern part, you have the Kuroshio current. So the Kuroshio current is equivalent to the Gulf Stream that you see here. So here you have the Kuroshio current. Meanwhile, here also polar easterlies will exist. Here also polar easterlies will exist, isn't it? So these polar easterlies will induce a motion for the currents here, and that, or movement of water here. That water movement will then be directed by the shape of the coastline,
কিসের দাগ লাগছে
and that is where here also you observe the bend. Bend is in the rightward direction, right? Now here, that is the Oyashio current, the cold Oyashio current, which is equivalent to the cold Labrador current here. So the cold Oyashio current will meet the warm Kuroshio current. This will also form the ideal fishing ground. It will be very good for fishing. Now, then you have the North Pacific current, just like the North Atlantic drift. This will be driven further by the westerlies. The westerlies will be dragging it towards the east. Now, this will hit the coastline here, right? It will get bifurcated into two. Now, the same ocean current, when it travels further into the higher latitudes, it will be considered to be a warm current. That is what you have as the warm Alaska current, right? And the same current, it is diverted to the lower latitudes, but the lower latitude, the temperature of water is higher. So the same current, just like in the case of the cold Canary current, you have the cold California current here, because it is the California coastline. And that cold California current then completes the circulation overall. Whereas in the case of the southern equatorial current, here it will hit the Australian coastline. It will form the East Australia current, just like the Brazil current here. It will form the East Australia current. Here also it will get subsumed by the west wind drift, which is a circumpolar movement in the Southern Ocean. This west wind drift will again deviate to the left, right? It will again deviate to the left. And here you have the very cold Peru current, or what is also referred to as the Humboldt current. So this is the Peru current, what is also referred to as the cold Humboldt current. Okay, that is what we have as the cold Humboldt current, which finishes the entire circulation. Okay, so here also you have a very ideal fishing ground, just like in the case of Atlantic. In the case of Atlantic, where was the ideal fishing ground situated? Where the Gulf Stream and the Labrador current would meet. Here, where the Kuroshio and the Oyashio meet, that creates a very ideal fishing ground. But the situation significantly changes whenever we come to the portion of the Indian Ocean. And in the Indian Ocean, the situation changes primarily because of the shape of the Indian Ocean. Now, in the case of the Indian Ocean, it is something which is closed significantly from the northwards side. Indian Ocean is closed in the northward side. Unlike the case of the Pacific and the Atlantic, if you observe the Pacific and the Atlantic, they are open, right? They are larger open oceans. Here, you have a closed scenario. So here, because the northern Indian Ocean is closed and is very smaller, so the impact of wind direction created because of the frictional drag of the wind, etc. So that is where the impact of wind movement will be very high. The wind movement impact will be exaggerated here. So that is where, with the shift of the or the change in the wind direction between various seasons, we have seen that during the months of April, or rather May, June, July, August, September, in that portion, you have the wind direction towards this. These are the southern trade winds, isn't it? So that is where the southwest monsoon. So that is where you will observe that in the northern Indian Ocean, the shape of the ocean current in the northern Indian Ocean is clockwise during the case of, or during the months of, advancing monsoon or southwest monsoon. Which are the months? That is June, July, August. These are, or even September, these are the months that you will experience, even in May. Then, in the month of the retreat and the northeast monsoon, that is December, January, so November to January, February, in a way, you will observe that the wind direction has reversed here. Wind direction has reversed. So when the wind direction reverses, here the winds will blow like this. The winds will blow like this. So that is where you will observe the northeast monsoonal currents, which will be counterclockwise. So here, only in the northern Indian Ocean, the ocean currents, they change their direction between the seasons, because the northern Indian Ocean is closed by the land mass. So there will be a greater impact of the wind, and aided by the frictional drag by the wind. That is why the ocean currents, they change their direction as the winds also change their direction. Whereas in the southern Indian Ocean, it is something which is very similar to southern Atlantic, very similar to the southern Pacific. It is only in the northern Indian Ocean where you observe these marked differences. Okay, so here, basically, observe that in the south equatorial current will be there. It will be divided by the Madagascar islands. So here you have the Mozambique and the Agulhas current. It will be subsumed by the west wind drift. That west wind drift will again divert here. So earlier you had the Peru current in Pacific, you had the Venezuela current in the Atlantic. Here you will have the cold West Australia current. That will be the cold West Australia current on the western coast of Australian continent. So that is how you have this circulation. The Leuven current that you see, this is a very minor current. So this is a very minor current which you will observe. This Leuven current will be bringing waters from the region of the Pacific very slowly and steadily into the portion of the Indian Ocean. So that is where you will find the weak Leuven current, which will help in mixing the waters from one region to another. Okay, right? Write it down. What write it down? What do you want me to write down, Gaurav?
পড়বি কিন্তু
Do you have a pen and paper? Kindly take notes. Okay. Eventually, you will have to write it down on your own when the question comes in the exam. In Pacific Ocean, if the winds are going from east to west, interacting with each other. So are you talking about the counter equatorial current, Sakshi? So that counter equatorial current is very weak. It is almost negligible. And that is aided by the movement of the planet. So here, many of the times, the winds in the region, we have discussed in the case of the doldrums as well, that it is not as if the winds will collide and then rise up in a portion. The winds will have a flow around the region of equator exactly. You don't have much of a wind flow. So that is where you have the counter equatorial current. Okay. November to February. So, okay, how many of us have not had any revision about the portion of monsoon? We have simply attended the portion of monsoon. We are happy that monsoon is getting over. We are happy that the geography sessions are getting over. So let's enjoy that. So I hope we are able to understand that in the case of the Indian Ocean, in the case when we talk about the Indian Ocean, Northern Indian Ocean in particular, we have the reversal of winds. The reversal of winds happens between various seasons. So in the case of the Northern Indian Ocean, Northern Indian Ocean, yeah, in the case of the Northern Indian Ocean, winds reverse their direction. That is what is the monsoon. Winds reverse direction. So during the months of, when we talk about the months in general, so months of June, in fact from May itself, June to September, what is the direction of wind movement? Southwest to northeast. During the months of November to February, the wind direction is northeast to southwest. Why? Because of the shifting of the ITCZ. The ITCZ comes towards the region of equator, and these are basically your normal trade winds of the Hadley circulation. So that is why you have this kind of a circulation. Is that understood now? And why does it revert their direction? Because of the shifting of the ITCZ. Voice is breaking. Rashida, it might be because of the pain that I see on the type of questions. That is why. West wind drift overall in the southern hemisphere, Kumari, is because of the aspect of the uh, around the region of southern ocean. You have the presence of westerlies, and these westerlies will drag it, and that is why it is west wind drift. Okay. March, April, and May. March, you will still have the motion in the in this particular direction, right? Here in the month of March, the movement is slightly weakened. Does new wind current help Bay of Bengal create low pressure? Sometimes, not always. Sometimes, yes. And tomorrow is class or not? No, tomorrow is not a class. How counter equatorial current develops? Counter equatorial current is developed as a result of the circulation or rather rotation of the planet. So rotation of the planet drives the accumulated water around the region of equator along the same direction as the rotation, and that is what is referred to. Let me write it down so that yes, you will get the entire notes in in the additional reading material. So when we talk about the counter equatorial current, no, the circular portion or the circulation in the middle of the ocean, they are not cyclones.
Onju?
They are what are referred to as eddies and a part of the Rossby wave. Okay.
Onju?
So here, when we talk about the counter equatorial current, they get generated. So the north and south equatorial current lead to the accumulation of water across the western coast of the continents. Okay, accumulation of water across western part of the oceans. So here, what it leads to is this accumulated water is influenced by continuous rotation of planet from west to east. This induces a movement, a weak movement of water from west to east. That is counter equatorial current. Is that understood now? It is this rotation, by the way. Remember, we had studied MJO, Madden-Julian oscillation. If you can recall, sometime in the past life, you had studied the portion of Madden-Julian oscillation. I don't expect you to remember in this life, but sometime you have studied that. There also we had seen a west to east translation that is also aided by the rotation of the planet, right? So here, this also aids rotation, also aids a very weak movement of air at equator from west to east. These are known as equatorial westerlies. These are referred to as equatorial westerlies. I hope it is understood now. May you slightly elaborate the part of Pacific Ocean current after East Australia current? Okay. So basically, even in the case of the Southern Pacific, the movement is same as you observe in the case of Southern Atlantic. It is same as you observe in the case of the Southern Indian. Here also you will observe the East Australia current will also bend slightly to the leftward. Now here it will get subsumed by the circumpolar movement. Excuse me. So here you will observe a kind of a circumpolar movement, that is the west wind drift, which is present in the Southern Ocean. And I have written here already that it is induced easterlies. So that is where this warm East Australia current will be subsumed. Furthermore, as you move to the east, this warm Australian current will get deviated and diverted to the left, and that will form the cold Peru or the Humboldt current. Okay, I hope that is understood. Now we come to the part of the global circulation of the entirety of the oceanic water, and that is the global conveyor belt or the global oceanic circulation. One part of that global oceanic circulation, which exists in the region of the Atlantic, is referred to as the Atlantic Meridional Overturning Circulation, what is also referred to as AMOC. Okay, so what is this global circulation? They also keep on mixing with each other. So these oceanic waters, you will find they induce a kind of a thermohaline circulation where this particular portion, warmer waters will go to the higher latitude, they will sink, they will come back, and they will move at a deep subsurface. And wherever they get heated up, they will again rise, move as a surface current. And that is how the heat and the nutrient across the entirety of the globe that will get circulated. So this is the global oceanic circulation. Global oceanic circulation. So that basically means that this oceanic circulation is also going to help in distribution of heat and distribution of nutrients across the oceans of the world in general. Now here, even though the image is not very accurate here, this is just a schematic representation. This warm current that you see, this is actually Gulf Stream. So Gulf Stream, when it reaches to the northern extent, to the higher latitude, some part of it cools down, and then as a result of the thermohaline circulation, it reverts back. The portion of global circulation in the region of Atlantic, that is what is referred to as the AMOC, Atlantic Meridional Overturning Circulation. So the global conveyor belt. Are we aware about the meaning of the term conveyor belt? Any of us who is not aware about the meaning of the term conveyor belt? Okay. Conveyor belts, basically, you would have seen in industries, in floor lengths, even in the case of the walkways, escalator, where you have in the malls, you would have gone, seen the
কি পাপা
escalator. This is a conveyor
কি
belt
কথা মেলো না
where
বাড়ি
it is having a motion somewhat like this.
হ্যাঁ আমার ভাবি ভাবি না
Is that now something that you can
হ্যাঁ
recall?
খাবো
The walkways, etc. Yes, the airport belt. Also take that also. Conveyor. Right? So now you are aware of conveyor belt. So conveyor belt basically represents a kind of a circulatory motion. So that is why the global conveyor belt, yes, like a treadmill. Okay. Now here, global conveyor belt is a system of ocean currents that transports water around the world. While wind primarily propels surface currents, the deep surface currents or the deep ocean currents are driven by the
নষ্ট হয়ে
thermohaline
যাবে বাবা খেতে
circulation.
পারবা না তারপরে
They are driven by the thermohalation overall. Okay. Now here, the density depends on the, so thermohaline circulation is driven by the factor of density, driven by both the temperature and salinity. Along the conveyor belt, heat and nutrients are moved around the world in a leisurely 1,000-year cycle. So in order to complete one entire circulation across all the oceans of the world, it will take close to around 1,000 years. We have been able to monitor this only for the past 100 years or so. Right. Now, the portion of the
পড়ুন করছিস
conveyor belt which is present in the region of Atlantic, that is AMOC. So the Gulf Stream is a part of the Atlantic Meridional Overturning Circulation. As warm Gulf water approaches the North Atlantic, it cools, releasing its heat to the atmosphere. As it cools, the water becomes more salty and dense and sinks to the bottom of the ocean. The Gulf Stream and AMOC are a part of the larger process of thermohaline circulation. This describes the interaction of surface currents like Gulf Stream and deep, slow moving underwater currents, which helps to mix ocean waters, salts, and even organisms on a global scale. As ocean temperature and density contribute to temperature change in the atmosphere, conveyor belt also contributes enormously to the climate of our planet. Now, why have we covered this is primarily because this has been in news
নষ্ট হয়ে যাবে খেতে
significantly.
পারবি না
This has been in news because of the various different news reports that the AMOC or the Atlantic portion is slowing down. So the Atlantic portion is slowing down means that circulation that you see, the thermohaline circulation that you see. So the thermohaline circulation will be like a conveyor belt. Let's suppose we consider this to be the Gulf Stream. Gulf Stream moves to the higher latitude, cools down, salinity increases, density increases. You have a flow. Now, what is happening is that understand why it is slowing down. So, what actually happens is that due to global warming and climate change, the polar region, the temperature of the polar region is also increasing. As the polar region begins to heat up, as the polar region begins to warm up, so in that situation, what do you think will be the condition here? Here, why is it that the currents are sinking or the water is sinking? Because the water is becoming very cold as it comes to the polar area. Some portion of it gets frozen, salinity increases, hence it is sinking down. But if the temperature at this portion increases, let's suppose,
পেন দেখেন
that means the water
ফুটা
won't
করবি
cool
না
down
কিন্তু
anymore. The water will continue to stay warm itself. When the water continues to so due to global warming, the Gulf Stream is not sinking, a slowing down
তোর কথা
of
মানা
the
করলাম না
AMOC. So due to
আবার
global warming,
পেন ডাক
warming, AMOC is slowing down. Now, when AMOC is slowing down, that means it will lead to a kind of an inefficient translation of heat from the lower to higher latitude. It will also lead to the inefficient movement of the nutrients from lower to higher latitude, isn't it? And also, as the AMOC is slowing down, what do you have? You will have the condition that the water will stay in the same region for a longer period of time. So if the water, if this entire circulation is broken, water stays in the same region for a longer period of time, means in that area, water will get significantly heated up, isn't it? Water will get significantly heated up. Now, once the water gets significantly heated up, what will happen to the temperature there? What will happen to the temperature of the water? If it remains in the same region, it gets heated up, its temperature will rise. And once the water temperature rises, what kind of phenomena do we experience? We experience cyclonic events. That is one of the reasons why
নষ্ট
now
করে না
the
খেতে পারবি না
planet
তুই ওটা
is
তারপরে
experiencing significant amount of cyclonic events. That is reasons exorbitant rate. Okay, so it will have a the ocean area as this AMOC slows down. Yes, ice will also melt. Good. Now comes the so mixing of warm and help to replenish the oxygen and thereby of plant, that is the algal species, the primary food for the fish population. So that is where the fish population increases. So the best fishing grounds of the world are mainly these mixing zones where you have the mixing of the warm and the cold ocean currents. Those are the best fishing grounds of the world. Then here, cold ocean currents, they are also responsible for the creation in the west part of the continents. So if I take you back, basically, observe. Here also you have the cold West Australia current. Here you have the Victorian desert. Here also you have the cold Peru current. Here you have the Atacama desert. Here you have the cold Mojave desert. Then here also you have the Beniguela current. You have the Namib Kalahari desert. So the cold ocean currents, they end up so think about it, apply your logic. You know this all to the land area. So let's suppose we consider water. Let's suppose the water is very cold. Very cold in the sense average temperature at the same latitude. So what will happen to the air here region? What happened to the air temperature, will it be warm or will it be cold? Air temperature will also be cold. So when something is hot here, temperature is cold. Right? Now, if the air temperature is cold at the surface, what kind of atmospheric condition will it create? Can we say it will create a condition of temperature inversion? Can we say it will create a temperature inversion? Right? So this creates
Whatever
temperature
with you.
inversion. Temperature inversion. And whenever you have temperature inversion, what happens to the probability of rainfall happening in that area? That reduces. So hence, little to no rainfall. No rain. Okay. So here you have little to no rainfall, which is observed in this area. So that is why you have the deserts. So be it in the region of the West Australia, you have the Victoria Desert. Be it in the region of the California current, you have the Mojave Desert. You have the various different desert, Chihuahua Desert also. Then be it in the cold Peru current or the Humboldt current, you have the Atacama Desert. Then Beniguela current also creates Kalahari and Namib Desert. So you have the creation of these desert-like features. Okay. No, Thar Desert, why will Thar Desert be impacted by the ocean current? Thar Desert is very far away. So Thar Desert is not on the coastline, is it? So that is why Thar Desert, we have already discussed why the region of Thar is a desert, and that is because of the alignment of the Aravallis. Okay. Now, why temperature inversion? Because here you have the cold air at the bottom and warm air at top. So that is the condition of temperature inversion. Why cold and warm currents are intersecting at the coast of Brazil? So Falkland current will deviate to the leftward direction in the southern hemisphere, and warm Brazil currents are coming from the north. That is why they will mix. Okay. Now we come to the portion of Sargasso Sea. So Sargasso Sea was basically, it is a region of absolute calm in the northern portion of the Atlantic, that is in the tropics of the Atlantic. This converges with the subtropical high pressure belt. Subtropical high pressure belt, that is the horse latitude, means will you have rainfall there? Almost negligible amount of rainfall there. Right? Now, it was something which was discovered way back in the 15th century when you had the Portuguese sailors, when they were moving across the Atlantic to discover the newer areas and newer lands. They came across this region where water was absolutely calm, was not moving at all. Now, the water was calm, and in those calmer waters in the oceans, you had the growth of seaweed. So, this was the growth of seaweed. Okay, this was the growth of seaweed. So, from top, it appears like a brownish cover. It basically is a brown algal species. So that is the brownish appearance. And the cross section appears like this. While this is very good for the biodiversity in the region, it can be a nightmare for navigation and shipping. In the sense that if you have to carry out shipping in that region or navigation, the movement of ships, oftentimes these weeds, they get entangled in the propeller of the ships, the hull of the ships. And that is where the ship experiences breakdown and it lies stagnant in the same region. So these seaweeds, they were referred to as sargassum in Portuguese. So they are referred to as sargassum.
এবার একটা বডি স্প্রে নিতে হতো না?
তো তোমাকে বললাম যে রোলটা অর্ডার করছে।
And hence the name which was derived was Sargasso Sea.
আমার ফোনে তো মিশো ঝ্যাকঝ্যাক করতেছে।
মিশো না তো কেন? মিশো ছাড়া অন্য জায়গায় পাওয়া যায় না?
Okay. Now, why is it that basically you have the creation of a condition of calm. That is because of the subtropical high pressure bed, and also aided by a complex phenomena that is referred to as the Ekman spiral. You don't need to go into the detail of that, but basically here what you will observe is that the ocean currents, in a very simplified form, if I try to tell you, the ocean currents, they will be moving aided by the wind movement and also aided by the Coriolis force. There will be movement, there will be movement, there will be movement, but eventually the movement will reduce. As you move towards the center, the movement will reduce. So that is why in the central portion, all around it, you will have circulation, but in the central portion, you will have the calm. So that is why it is said that the Sargasso Sea is the only sea which is not surrounded by land. Any other sea that you consider, it will have one or the other land boundary. Sargasso Sea is not surrounded by land at all. In the north, it is surrounded by the North Atlantic Drift. It is bordered by the North Atlantic Drift in the north. In the west, it is bordered by the Gulf Stream. In the east, it is bordered by the Cold Canary Current. And in the south, it is bordered by the North Equatorial Current. So it is bordered by the various different portions of the Atlantic Ocean, driven by the various different oceanic currents of the Atlantic Ocean. But here, you have an absolute calm condition. Okay, that is why the seaweeds, they grow in significant proportion. These seaweeds, while they are a nightmare for navigation and fishing, these seaweeds, they also significantly help in the biodiversity of a region. They can be used for medicinal purposes. There is great amount of research being carried out for the medicinal utilities of the seaweeds as well. Okay, sargassum is Portuguese for seaweed. Okay, it was the Portuguese sailors, and in fact, even the ocean current, Gulf Stream, etc., all of these were initially discovered by the Portuguese themselves. These were the sailors who would go through the entire region of the Atlantic. Sometimes, if you get an opportunity to read about the activities of the merchants and the sailors during the 15th, 16th century, your mind will be boggled by the bravado that they had to go into uncharted territories with very little amount of resources. They would be given some amount of resources by the government, by, in many of the cases, the churches, and they would be asked to explore newer areas. And all of them, they would venture out into the sea. They would bring whatever they could. Many of them would die and perish in the sea itself. And it was during these journeys where eventually the Spanish Armada also followed. And that is where it was during these journeys that we got to know about the planetary wind system, about the oceanic circulation system, about the features of the oceans as well. Okay? Now, then what causes the seaweeds? So the calm conditions, the lack of any movement in the oceanic water, that creates the condition for the growth of seaweeds. Okay. Now, despite high temperature at deserts, they don't receive rainfall. No. So only high temperature, will it be sufficient for rainfall? Don't you need the availability of moisture for rainfall? So here moisture can be gained from where? From the surrounding ocean. But in the surrounding ocean, you observe what? Temperature inversion. So how will it get rainfall? So now we come to the portion of coral reefs. Before starting it, only I will tell you that we will discuss, or whenever you have the environment session, wherever you attend the environment session, you will be discussing in detail about the coral reefs, what species they are, the symbiotic relationship, etc. Here we are going to discuss about the basic geographical aspect of coral reefs. Now, coral reefs, they are also referred to as the rainforest, tropical rainforest of the water ecosystem or the marine ecosystem. Now, these coral reefs, they basically present a kind of a beautiful, picturesque scenario underwater. Now, these are made up of all these reefs. They are made up of individual organisms which we refer to as coral polyp. Coral polyp. Okay, they are known by individually they are made up of coral polyps. Now these coral polyps, they are very simple organisms. These are animals, by the way, where you will find these organisms having a simple digestive tract, a simple digestive system. So here, basically, you will have the digestive mechanism. Right. Now here you will have the tentacles. These tentacles are there to capture food and catch food. And on these tentacles, you will find the presence of many smaller organisms of algae, what is referred to as the zooxanthellae. That is a symbiotic relationship, mutually beneficial relationship. Here you have the algae, that is zooxanthellae. Okay, that is what the coral reefs they constitute of. So basically, if you observe this, it is a kind of an underwater ecosystem characterized by the reef building corals.
নাই
Reefs
তো
are formed
আওয়াজ
of colonies of coral polyps held together by materials such as calcium
কবে
carbonate.
সেদিন
Calcium carbonate is calcium and carbonate, all these ions are present in the oceanic water. So when we talk about calcium carbonate,
কোথা থেকে আসছে
so
এটা
they are held together by the presence of calcium
হ্যাঁ
carbonate. And why? Because the coral
রিপন
polyps, they
রিপনটা
synthesize the calcium and carbonate ions
রিপনটা
present in the oceanic water, and they build a
সবাই
very
এখন ঘুমাইতে
hard
পারছে
stony exoskeleton around them. That is why they appear whitish in structure. So that because calcium carbonate is also whitish or brightish in structure. So here, these coral reefs are built from stony corals whose polyps cluster in groups. The largest
এই যে
coral
ওই যে
reef
লেবুটা
is the
দিছিল
Great
এত
Barrier
টক
Reef, which spans for a distance of close to around 2,600 kilometers, something which can be visualized from the space as well. So corals are basically an ideal represent, not all the corals, by the way, warm water corals. Warm water corals are the idealistic representation of what we refer to as the condition of or the mutualistic relationship between an animal and an algae. So here, this is your coral polyp. Coral polyp. Okay, so this is a kind of a symbiotic relationship which is
বিস্কুট চা
mutually beneficial for all of them. So while the algal species they get a platform and availability of nutrients such as calcium carbonate where they can grow and they can thrive, the corals in turn, they generally they don't get adequate amount of food because these corals they
ওটা
cannot
কেটে
move.
যাবে কিন্তু ওটা
They are
ধার আছে
fixated
কোনগুলা
at the same place. So basically, as they are fixed at the same place, they rely on the movement of the tentacles to capture food. Now, many of the times the food is not enough. But these zooxanthellae, which also impart the different coloration that you see in the corals, they are able to carry out photosynthesis. So this is, they carry out. Yes, this belongs to the species Cnidaria, the branch of species that is Cnidaria.
কই পেয়েছি
Corals are animals, my dear
এই যে
friend. So here, carry out photosynthesis. Don't worry
সব জায়গায়
about the
খোঁচায় বাড়াবে তো
condition
কি
of
হবে
corals in detail. You will study in environment and ecology. Time and again, I'm telling you, don't fret about it. You will study in significant detail what are the conditions required, why coral bleaching happens, everything you will study in detail. Okay? So they carry out photosynthesis. That photosynthesis which is carried out. So here, this is helps in providing food to the corals. Okay, so that is okay. Many of you have no clue whether the corals are animals or plants in general. So these okay. So let me talk about the basics once again. So all these that you see, these are what are referred to as corals,
আর হয়ে
right?
যাচ্ছে মনেই হয় না
Now the different coloration that you see, that is not of the corals themselves. corals themselves, they are stony white in appearance. If you take a look at the original shape, this or original coloration, this is the original coloration of the corals overall.
খাবি
It
ঠান্ডা নেই
is given a color because of the presence of the symbiotic algal species that we refer to as the zooxanthellae. The
এই যে লেখা
zooxanthellae is able to manufacture food, and that is why
আরে লেখা
symbiotic
দেখা
relationship
কালি
is what? Symbiotic relationship is when a relationship exists between two organisms where both organisms, they benefit out of each other. That is what is referred to as a symbiotic relationship. Okay, so these corals are actually animals. They belong to the branch of species which
কে
we refer to as Cnidaria. The branch of species which is referred to
পড়বি
as
কত ওই
Cnidaria.
যে কত পড়লো
They are fixated to the ground. They don't move across the ground. These are the animal species which gets fixed to the ground. So these species have the ability, the common body morphology is somewhat like this, where these species, they have the ability to synthesize the calcium ions and also the carbonate ions, and they make calcium carbonate, CaCO3. So that calcium carbonate, they utilize it to build that
হ্যাঁ
stony white exoskeleton around them and also fix themselves on the ground. Many of these coral species, they have a lifespan of hundreds and even thousands of years. So they live for a very long period of time. They can exist underwater, but where underwater? So you have the categorization further into warm water, cold water corals. But when we talk about the warm water corals that we are referring to right now, they will always be in existence in the shallow region where the water is not very deep. Why? Because they need the availability of sunlight. Why? Because with the availability of that sunlight, that is what is utilized by zooxanthellae, and that is where the zooxanthellae, they carry out the photosynthesis to manufacture their own food. Okay, so that is why they will always grow in shallow marine waters. They grow in shallow marine waters. They don't grow in fresh water or muddied water. They require clear water. Average consistent temperature. Consistent temperature around 24 to 26 degrees Celsius. Because all the marine species in general, they have a very little thermal tolerance. Why? Because historically, for millions of years, they have been living in the region where the temperature does not change drastically. We have seen that the temperature changes drastically over the land, but the temperature never changes drastically over the water body. So because the water body always exhibits a kind of a consistency in temperature, that is why all the marine organisms, most of the marine organisms that you will encounter, they suddenly get distressed when the temperature changes anymore. So here, these corals, they require these kinds of conditions. The warm water corals we are talking about. We are talking about water corals. They will require nutrients to grow, and the coral in return gets food by the food manufactured, the organic matter manufactured by the zooxanthellae. It is a zooxanthellae which gives the coloration to the corals. Coloration to corals. So all these vivid colors that you observe, these are the different species of zooxanthellae. That is why you have these colors. Okay, so they will
পড়বি কিন্তু
always be found in shallower waters. Now, when the zooxanthellae carries out
পড়বি
photosynthesis,
বলছি
The byproduct will be what? Organic matter and oxygen. So they provide oxygen into the marine waters, and also food in form of organic matter. Now that is why these corals, they are able to house a very large variety of biodiversity. And it is because of that reason that they are also referred to as the tropical rainforest of the marine ecosystem, because the rainforest, they also manufacture oxygen, produce oxygen as a result of photosynthesis, and the rainforest, they also have the ability to house a large number of species. So something on the very similar scale will be observed in the corals as well. There are deep sea corals as well, there are cold corals as well, you have the black corals as well, where you don't have the symbiotic relationship at all. Okay. Now these corals, where basically many of these corals, they will exist for hundreds of years and thousands of years, and in that time they will build a calcium carbonate exoskeleton around them. When they die, they will leave behind that calcium carbonate exoskeleton. So let's suppose you have this as the level of water. Again, I would say corals are fixed. Corals do not move. That is why they have the calcium carbonate. I understand it is almost impossible for you to imagine an animal which cannot move, but these are the animal species which cannot move. You would have come across Hydra as well, the species of Hydra, right? All these, is it that the school syllabus has changed very drastically since we graduated or we moved from school? Is it that the school syllabus, they have removed all this? Or is it still taught in the 7th, 8th, 9th standard? Animal Kingdom you would have studied in class 9. If you are able to recall the portion of class 9, I'm sure some of you would have attempted class 9 after me, right? So please, so either in ninth or 10th, it would be there, isn't it? Right. So basically, coming back to it, when we talk about these here, let's suppose this is the base, or let's suppose we consider the coral ecosystem here. Now, these corals, if they grow here, they will leave behind a kind of a thick calcium carbonate exoskeleton behind them. And by the way, guys, please don't get disheartened if you don't remember these things. It is absolutely possible that we have not paid much attention in our school days and school classes. It is absolutely possible we don't remember much of it. Please don't get disheartened. The solution to it is to pick up those books of class 6 to 10th of NCRT basic science. Just flip through it. Okay, just flip through it. You don't need an advanced reading of graduation level science, etc., but that 10th level science, you should not be relying on the science and tech classes for that. That basic information, if you have, it will help you not only in your UPSC journey, it will help you correlate and understand many of the perspectives. Many of us, I have seen that we have problem in understanding what is melting, what is boiling, what is latent heat of condensation, vaporization. We have problem in that. So don't have any ego in yourself. Don't wait for someone to teach you that, because these are for the 6th, 7th, 8th, 9th standard. I'm sure you would have been, or you are one of those who has already completed those sessions. So kindly go back and pick up those books one by one. Pick up those books, and at this stage of your life, you will be able to complete those books maybe within a week or 10 days if you go for a dedicated study. But the kind of confidence boost that it will give for many of you, I see, and many of you do require that confidence boost. So do that. Be ready to put in the hard work. Okay, this is the civil services examination. It requires hard work. Put that hard work. There won't be any disadvantage whatsoever. Okay. Now, these are basically which have died. Now, after they have died, the next generation corals will utilize this base of calcium carbonate to grow furthermore. Okay, they will grow furthermore on top of this. Now, while they are growing, these will also synthesize calcium carbonate from the surrounding and they will also deposit them. Then the further generation will also do that. Then the future generation will also do that. It will continue to happen.
মার খাবি কিন্তু এখন বলে দিলাম।
It will continue to happen. Eventually, it happens up till what point? Eventually, it will come above all
দাঁড়া,
these
ভাইব্রেটর
are
দাও তোমার,
the
ভাইব্রেটর
calcium
দাও তো।
carbonate exoskeletons left behind by the previous generation. Calcium carbonate exoskeletons left by previous generation
ও সরাও তো ওখান থেকে।
of corals. Okay, so they will continue to grow, and here, yes, Shubham, exactly like that. So it will continue to grow, and the corals will continue to grow on top of that till the point that these come above water. The moment they come above water, that is when they will die, because after all, these are marine species. These cannot even survive in river water. They will be surviving only in marine waters, and these are the various different marine species out there. Now, the moment it comes above water, then few of the interesting things happen. So once they die here, so you are left with a kind of an island of sort formation with the rocks dominant in calcium carbonate. Can we say that this will be dominant in calcium carbonate? We can say that, isn't it? Now, this calcium carbonate in general, calcium in general is whitish in color, right? So here, this calcium carbonate will get degraded, eroded, etc. You will have the formation of white sands in this region. Significant amount of white sands you will observe in this region, isn't it? Now, it might be possible that a traveling bird would be moving through here, dropping some of the seeds, taking shelter. The migrating birds, which move for thousands of and hundreds of kilometers, they might take shelter here. When they take shelter, they might drop a seed or two. Few of them might germinate in the conditions of moisture and sunshine. And you will have what? You will observe within a few, let's say, hundreds of years, you will end up observing the growth of trees and plants in this area. You will observe the growth of trees and plants in this area. So, like this, what do you end up finding is a kind of a creation of an island. But this island has been created purely because of the corals, right? This island has been created purely by the existence of the corals. So such islands are referred to as the coral islands. Okay. For example, you have the Maldives, you have the Lakshadweep region. You will also observe the growth of certain mangroves in this area, mangroves across the coastline. And you will have the development of the coral island. This is what is a coral island. So example of coral islands. So that is basically coral islands.
বললাম তো যদি আমার লাগলো।
So this example you have Lakshadweep. Lakshadweep, Maldives. Now in all these areas, you will notice one particular fact. And that fact is that the sand in this region will be whitish. It will not be the brownish sand that you generally encounter. Certain areas you will have the brownish sand brought by the sea wave, which will bring the brownish mud and sediments and sand in the coastline. But generally, in these islands, you will find whitish sand to be predominant. Why? Because it is formed by the disintegration of calcium carbonate. Bahamas also, many portion of Bahamas, Caribbean also. Okay, so that is what is the coral islands. Mostly coral islands are in tropical regions, Kumari. That is because these are the warm water corals that we are talking about. And it is only the warm water corals which eventually over thousands of years will form these coral islands. Okay, so these are the areas where you have the coral islands. So the region around Indonesia, Philippines, Australia, then Solomon Islands, Papua New Guinea, Malaysia. These are the areas which contribute or have more than one third of the coral population across the world. And that is why it is also referred to as the coral triangle, right? Where you have significant amount of coral population. In India also, in that entire stretch from Lakshadweep to the region of Maldives, you'll find significant amount of corals. But you will not find these corals in the region where there is lot of mud. There you will not find it where you have lot of sediments. They will grow in clear saline water or clear marine water. Why? What if there is pollution and mud? Why won't it grow there? Because in those conditions the sunlight gets blocked and the zooxanthellae population that dies. Once the zooxanthellae population starts dying, then the corals are reduced to their stony white structure themselves, and that is what is referred to as coral bleaching. So coral bleaching happens. Bleaching is what? A whitening. Bleaching is something that you would have carried for your, let's suppose, in certain cases, your bedspreads, for suppose your table spreads. You carry out the bleaching. Now, what is that? That is a whitening activity. So sometimes due to adverse circumstances or conditions, you have the zooxanthellae population which escapes these coral polyps, which dies also, and that is where the corals are left without zooxanthellae. They can survive like this for a few days, for let's say a few weeks. But if the conditions don't revert back to normalcy within 45 days or 60 days, that is when the corals they die because of lack of food. So that is where coral bleaching leads to mortality of the corals. Leads to mortality of corals. Okay, they start to die, right? So when basically the zooxanthellae population is now, why will it escape? Let's suppose suddenly the temperature has risen, there is a sudden marine heat wave which has been created, the zooxanthellae will die. Let's suppose there's a disease, zooxanthellae can die. Let's suppose there's solid waste dumping or pollution, marine oil spill, zooxanthellae will die. So any of these adverse activities will lead to of the zooxanthellae. And once the corals they die, the entire marine ecosystem is impacted so significantly and so heavily, because once the corals are dead, means what? Means there won't be any more supply of oxygen in that area, means there won't be any more organic matter to be produced in that area. So it is a disaster for the aquatic ecosystem, right? Now, these corals, depending upon where they are found to be in existence, they are divided into these corals, they form reef. So they are divided into fringing reef, barrier reef, and atolls. Basically, it is dependent upon where they are growing. So generally we have seen that how is it that new land gets created in the ocean. And here understand this entire process is worth millions of years. So new land gets created due to volcanic activities. It can happen that after, let's say, volcanic activities have stopped, you have a volcanic island or an island in between. So in those areas, in the cases of the islands, on the sides here, you will observe the growth of the coral population and the coral species
কি হয়েছে?
in the
মাকে বলো খুলে
shallower
দিতে, মাকে
areas.
বলো খুলে দিতে, যাও মার কাছে যাও।
So when you observe the growth of the coral species in the shallower waters. These are on the fringes of the land, hence the fringing reefs. Now these develop the individual polyps, they will develop the calcium carbonate exoskeleton, they will fixate themselves to the ground. Now let's suppose over a period of 10,000 years, the land begins to subside due to endogenic forces. We have seen that the land can get uplifted, the land can also subside. So let's suppose the land begins to subside, the land sink. As the land sinks, the coral which had built a calcium carbonate exoskeleton fixated itself. It will stay where it is. But the land has started sinking. So there, water will come in between. A small lake-like portion will be created. A large water body might get created. And you will have many of the coral islands in existence. This forms a kind of a barrier around the land, and that is what is referred to as a barrier reef. Let's suppose this subsidence continues and the entire land has then sunk. You are left with nothing but the coral islands. That is the atoll. Okay, so here fringing reefs, they are formed along the coast of the continents or islands. Their surface is connected with the coast and rises to the low tide water level in a rugged and uneven platform. So it is on the fringes of the landmass, on the sides of the landmass. Right? Observe, they have fixated themselves to the ground here. So if the central portion after some time will sink, this will continue to stay. Right? Majority of the corals that you find, they belong to this category, warm water corals. That is why you will find all these corals situated around the islands where you have shallower waters. Right? So that is where you have the fringing reefs. Then as the central portion continues to sink, why will the central portion sink? Not always will it sink. Sometimes it sinks due to endogenic forces, due to what we refer to as the diastrophism as well as the aperogenic movement in particular. So here, as the central portion sinks, the portion of the corals gets left behind and you have water which comes in between. That is the barrier reef. So they are situated away from the coast, and in between the coast and the reef, there's a relatively wide and deep lagoon. The reef is called a barrier reef. Now, when that sinks further, you are left with a chain of coral islands, generally in a horseshoe shape or a circular shape, which we refer to as an atoll. Right? So these are the most common type of coral reefs and are roughly circular or horseshoe shape. Now observe this image here. So here, basically, you will observe the whitish portion here. Posting the pictures on social media, you would have observed water appears very blue, turquoise blue. Here also it appears turquoise blue. And here the water is dark, dark blue. Here it is very light blue. Why? Because these are the exoskeletons of calcium carbonate. Calcium carbonate is whitish in color. That creates a reflection. That is why the water gives you that appearance. It is not as if the water is very clean here. It can be, but basically it is because of the calcium carbonate. So that is the corals and the growth of the corals. So overall, if you take a look at the entire chain formation, it is not greenish, it is what is referred to as a turquoise blue color. So initially you have a land created due to volcanic eruption from underwater. Now over a period of time you will observe the fringing reefs to develop. The central portion of the land, let's suppose it starts to sink, right? It sinks further, creates a barrier reef, right? So wherever you find barrier reef, at one point of time it would have been a fringing reef in general. That means the land in between has moved down. Then if everything sinks, you are left with a kind of a chain of islands, that is an atoll. You will find such atolls even in the region around Maldives, right? You will find these atolls in existence. So the corals are very, very important and relevant because they will support the wildlife in that area, the biodiversity in that area, a lot of fishes, tourism sector, And these corals, they also have medicinal benefits. So they are very important. Overall, they support close to around 500 million people. They earn their livelihoods due to fisheries, due to tourism, and all the direct and indirect benefits associated with corals. Okay. In Lakshadweep, you have a few islands which are example of atolls. Yes. Okay. Now, after this, we come to the questions. If we can, let's take a look at few of the questions here. So here, what is the reason for not mixing up of water at confluences? Because the water have individual different properties of salt presence, of temperature. That is why. Now, consider the following statements. In the tropical zone, the western section of the oceans are warmer than the eastern sections owing to the influence of trade winds. In the temperate zone, westerlies make the eastern section of the oceans warmer than the western sections. So I'll give you a massive hint. Yes, correct. Can we go on to purchase the property as it will subside? In all fairness, the property and the acquisition of property is very difficult in the regions such as Lakshadweep. Good. So here you have to indulge in the portion of which section are we talking about. So here the principle involved is downwelling. Downwelling is involved. So downwelling means you have accumulation of water. So western section of oceans in the tropical region. So western section. So if this is an ocean, so western section, eastern section. So trade winds will carry out downwelling here. That will lead to rise in sea surface temperature. So the first portion is correct. And then in the temperate region, you will have westerlies. Westerlies will carry out downwelling here, right? So that will increase the sea surface temperature. So both of them are correct. So the correct answer is C. Okay. Then this is an easy one. The most important fishing grounds of the world are found in the regions where warm and cold atmospheric currents meet, rivers drain out large amount of fresh water into the sea, warm and cold ocean currents meet, continental shelf. Of all the types of questions that you can ask, you are asking the question that where is the stomach of coral polyp? Okay, the brown section that you saw in the image of the corals, that is the stomach. Yes, all of you are correct in this. I would be very interested to know who gave the incorrect answer in this. So, where you have the warm and cold oceanic currents meet, that is where you have the ideal fishing grounds of the world. Tides occur in the ocean and seas due to which among the following? Gravitational force of the sun, gravitational force of the moon, the centrifugal force of the earth. Correct. Yes. Correct. Matlub, it increases the dissolved oxygen because it increases the interface property of the air and water. Gayatri, wrong. So here you have 1, 2, and 3. All of them are responsible. Consider the following statements. Most of the world's coral reefs are in tropical waters. More than one third of the world's coral reefs are located in the territories of Australia, Indonesia, and Philippines. Coral reefs host far more animal phyla, that is, animal species, than those hosted by the tropical rainforest. So, here, take a calculation here and Then think about the answer. Atolls are generally on the outside, you will find it very deep, but in the central portion, not very deep. Yes, Garvit, correct. Tarun, correct. Good. Maria, Vivek, incorrect. Other Tarun, also correct. Manikandan, correct. Aman, good. So here, majority of you have given the incorrect answer. So while the first two statements are correct, that the most of the coral reefs are in tropical waters, more than 1/3 are located in the territories of Australia, Indonesia, and Philippines. The coral reefs don't host more amount of animal phyla than the tropical rainforest, because in tropical rainforest, if you consider the insect species, the butterflies, all of those species, the avian species, the arboreal species, the variety is much more. Okay. Now, this was a question of 2017. At one of the places in India, if you stand on the seashore and watch the sea, you'll find that the seawater recedes from the shoreline a few kilometers and comes back to the shore twice a day. And you can actually walk on the sea floor when the water recedes. This unique phenomena is seen at. Now, I've told you the answer of this in the session itself, so it will be easy. Yes. Correct. All of you are correct here. So I think there are 3 Taruns in the class, is it? No, Usha. Usha Sri, incorrect. Right. Uni, incorrect, my dear friend. Good. So here it is Chandipur in Odisha, which is the correct answer. Then we will come across the subjective questions. Later on, we'll take a look at it next week. Okay, why tropical rainforests are in? Because in tropical rainforests, you have far more number of species. Okay. So, right. So that is where we will end the session here today. That is where we end the portion of physical geography. We end the portion of the world as well, right? Because now you know the climate of the world, geomorphology of the world, oceans of the world, circulations of the world, climatic conditions of the world. Now, from Monday onwards, we enter into the portion of knowing our country in a better way. We enter into the portion of Indian geography from Monday. So that will be all from my side. And we don't have an extra class